Imagine a golden disk, etched with the sounds of falling rain and human laughter, sailing completely alone through the eternal night of interstellar space. It is a fragile time capsule, outliving its creators to carry the memory of a pale blue dot into a future we will never see. Picture a mechanical hunter, falling silently through the void for 10 long years just to catch a tumbling mountain of primordial ice. When it finally touches down, it tastes the ancient dust of a comet that has been frozen since the very dawn of our solar system. If we were to look closer at this cosmic contrast, the sheer scale of the universe begins to feel less like an empty abyss and more like a carefully constructed masterpiece. We have extended our senses billions of miles outward, using fragile structures of wire and glass to feel the cold of deep space on our behalf. This quiet room you rest in now is the safe harbour at the centre of all that magnificent exploration. As the weight of the day slips away, your body can sink deeply into the mattress, tethered securely by the gentle gravity of Earth. You are safe, and these wonders are yours to inherit as you sleep. Close your eyes and allow your mind to detach from the tether of the waking world, floating upward to join the sentinels of the dark. We are about to embark on a journey outward, leaving the atmosphere behind to find the ultimate quiet. Deep within the freezing void, a solitary ambassador carries the curated soul of our world into the great unknown. Deep within the freezing void, a solitary ambassador carries the curated soul of our world into the great unknown. Voyager 1 glides silently through the darkness, bearing a golden record that waits patiently in the unfathomable depths of interstellar space. This timeless artifact is etched with the gentle sounds of falling rain, the steady beating of a human heart, and a chorus of greetings spoken in languages both living and dead. As the soft hum of its ancient electronics drifts through the cold vacuum, the spacecraft acts as a lonely courier for a civilization bound to a distant yellow star. The copper disk, plated in radiant gold, is shielded by an aluminum jacket to protect its delicate grooves from the microscopic impacts of cosmic dust. It is a masterpiece of analog engineering, designed to survive for 1 billion years in an environment devoid of air, warmth, or life. Imagine the unimaginable distance this phonograph has travelled since it first slipped the surly bonds of Earth in the late 20th century. It carries a stylus and visual instructions, a hopeful puzzle waiting for a mind entirely alien to our own to decipher its hidden melodies. Until that impossible encounter occurs, it simply drifts outward, a silent symphony perfectly preserved in the eternal night. Surprisingly, the cold metal casing of Voyager 2 holds an entire vibrant world locked securely within its digital memory banks. As it plunges deeper into the uncharted territory beyond the heliosphere, it safeguards a staggering collection of encoded photographs that define the human experience. Deep within its memory, it stores the brilliant sunlit hues of shallow coral reefs, alongside the chaotic, bustling energy of modern city streets. If we were to look closer at the magnetic tape spinning sluggishly inside this ancient machine, we would find a meticulous archive of our home planet. It holds the frozen geometry of snowflakes, the towering majesty of giant sequoias, and the joyous faces of children running through a summer field. These images are mathematically translated into radio waves, a fragile tapestry of ones and zeros waiting to be unfurled by an intellect we have never met. The soft hum of its ancient electronics provides a steady rhythm to this endless journey through the cosmic ocean. Surrounded by an absolute and terrifying emptiness, Voyager 2 cradles these memories of blue skies and green forests like a protective mother. It is an electronic bottle cast into a boundless sea, holding the vibrant essence of Earth long after the shores it left behind have irrevocably changed. This cosmic structure, a delicate antenna dish of pristine white, acts as the only fragile thread connecting us to a wanderer in the abyss. Measuring perfectly across its parabolic curve, it is perpetually locked onto a tiny pale blue dot, lost in the glare of a distant sun. From over 15 billion miles away, it whispers precious data back to the eager ears of the Deep Space Network. Picture the immense patience required to listen to these transmissions, which crawl across the solar system at the absolute speed of light for nearly a full day. The signal that reaches our massive receiving stations on Earth is astonishingly faint, billions of times weaker than the battery power of a standard digital watch. Yet, through miraculous feats of engineering and noise-cancelling mathematics, we capture every stuttering syllable this remote traveller speaks. The soft hum of ancient electronics drifting in the cold vacuum is the only companion this high-gain antenna has ever known. It commands the craft, relays its startling discoveries, and confirms that humanity still has a functioning outpost in the interstellar dark. Without this incredibly precise, unblinking ear, the spacecraft would be forever deaf and mute, entirely severed from the hands that built it. Beyond the protective magnetic bubble blown by our sun, the cosmos reveals a shocking and chaotic true nature. For decades, scientists assumed the space between the stars was a perfect, pristine vacuum, devoid of any meaningful substance. Surprisingly, the universe outside our solar system is not entirely empty, as Voyager 1 discovered when it finally tasted the dense plasma of interstellar space. As the spacecraft crossed the heliopause, its instruments detected a sudden and dramatic shift in the invisible ocean it was sailing through. The sparse, hot wind of our sun was abruptly replaced by a thick, cold, and highly charged soup of particles ejected by ancient supernova explosions. This violent plasma hums and vibrates, ringing like an ethereal bell when disturbed by shock waves propagating from our distant star. If we were to look closer at this boundary, we would see a turbulent shore where the solar wind crashes against the tide of the galaxy. The soft hum of ancient electronics recorded this momentous transition, marking the exact second humanity officially became an interstellar species. Gliding through this dense cosmic weather, the probe continues to sample the elemental ashes of stars that lived and died before Earth was even born. Long before the golden records were pressed, an earlier emissary carried our first deliberate message into the galactic dark. Pioneer 10 paved the way through the perilous asteroid belt and the lethal radiation belts of Jupiter, surviving against all odds. If we were to look closer at its chassis, we would see a small, elegant plaque depicting humanity, precisely etched in gold anodized aluminum. This rectangular canvas features the stark, line-drawn figures of a man and a woman standing together in peaceful greeting against the backdrop of the spacecraft itself. Beside them, a cosmic map uses the immutable frequencies of 14 specific pulsars to triangulate the exact location of our Sun in the Milky Way galaxy. It is a brilliant stroke of universal cryptography, utilizing the spin of dead stars to draw an unmistakable treasure map leading directly back to Earth. The soft hum of ancient electronics has long since faded from Pioneer 10, leaving it cold, silent, and drifting blindly toward the constellation of Taurus. Yet, this golden plaque remains pristine, impervious to the biting cold and the ravages of time in the deep vacuum. It serves as a permanent metallic handshake offered to the cosmos, silently declaring that we existed, we were curious, and we were here. Deep within the core of these wandering explorers lies a miraculous source of energy that defies the freezing, lightless environment of the outer solar system. Far beyond the orbit of Mars, the Sun becomes too small and too dim to reliably power solar panels, necessitating a different kind of fire. Slowly, the radioactive heart of the Voyagers continues to beat, providing a crucial trickle of warmth and power through radioisotope thermoelectric generators. These vital engines are fueled by slowly decaying pellets of plutonium-238, glowing with an intense, furious red heat inside their protective carbon graphite shells. As the radioactive material breaks down, specialized thermocouples translate that intense thermal energy directly into the electricity needed to run the spacecraft's delicate computers and scientific instruments. It is a slow, controlled nuclear ember that has kept the mechanical lifeblood flowing through their frozen metallic veins for nearly half a century. Notice how the soft hum of ancient electronics relies entirely on this steadily diminishing nuclear pulse to survive the brutal extremes of interstellar space. Every year, the power output drops slightly, forcing engineers on Earth to make agonizing decisions about which heaters and sensors to permanently turn off. Eventually, the heart will grow entirely cold, but for now, it defiantly pushes back against the absolute zero of the void. Venturing boldly into regions where no human artifact had ever gone, a brave little machine charted a course through rings of ice and moons of rock. Following the trail blazed by its twin, Pioneer 11 executed a daring gravitational slingshot around Jupiter to aim for an entirely new, ringed target. Drifting far beyond the inner planets, it became the very first to fly past Saturn, feeling the tremendous tug of its immense gravity. This harrowing encounter required the spacecraft to thread the needle through the planet's outermost rings, a region fraught with the danger of high-speed collisions with unseen debris. As the soft hum of its ancient electronics echoed in the cold vacuum, it captured the first up-close images of the gas giant's swirling pale yellow atmosphere. It discovered a new faint ring and mapped the powerful invisible magnetic field that surrounds the massive, beautiful world. If we were to look closer at the orbital mechanics involved, we would realize how this close approach fundamentally altered the probe's ultimate destiny. Saturn's gravity grabbed Pioneer 11 and hurled it violently upward, tossing it entirely out of the orbital plane of the planets. It now sails on a lonely, unique trajectory toward the center of the Milky Way, carrying the memory of its historic planetary dance. The grand tour of the outer solar system was not merely a triumph of engineering, but a masterful exploitation of celestial clockwork. The sheer distance to the gas giants meant that flying directly to them would take an impractical amount of time and fuel. Fortunately, the journey of these early probes was guided by the incredibly rare alignment of the outer planets, a miraculous cosmic coincidence. This precise geometric arrangement, which occurs only once every 176 years, allowed the spacecraft to hop from one massive world to the next. By diving deep into a planet's gravitational well and stealing a tiny fraction of its orbital momentum, the probes accelerated to speeds they could never achieve alone. Jupiter hurled them to Saturn, Saturn threw them to Uranus, and Uranus vaulted them toward Neptune in a flawless game of interplanetary billiards. Picture the immense mathematical precision required to calculate a trajectory that would remain valid over a journey spanning 12 entire years. The soft hum of ancient electronics executed these perfect sweeping arcs, translating gravitational mathematics into an unprecedented voyage of discovery. Without this fleeting, lucky alignment of the spheres, our understanding of the outer solar system would have been delayed for generations. Initially built to survive a mere 5-year mission to Jupiter and Saturn, they simply refused to break down when their primary objectives were complete. The soft hum of ancient electronics drifting in the cold vacuum represents a triumph of redundancy, careful planning, and ingenious remote troubleshooting by generations of flight controllers. They are soaring monuments to human ingenuity, functioning perfectly on technology that is now considered incredibly primitive by the standards of modern smartphones. Surprisingly, these aging explorers continue to rewrite the textbooks of astronomy despite suffering from degraded sensors, failing memory banks, and freezing thrusters. They are managed by a new generation of scientists who were not even born when the rockets first cleared the launch pad in Florida. As they press onward, they carry the enduring legacy of a 20th century dream into the deep, unfolding reality of the 21st century. If we were to look closer at the profound significance of this reality, we find a comforting thought amid the terrifying vastness of deep time. The soft hum of their ancient electronics will eventually cease, but the physical monuments will endure until the galaxy itself fades. They are humanity's final whisper into the dark, echoing forever across a universe that may finally, one day, stop to listen. While those distant heralds whisper into the dark, a much closer neighbour commands our unwavering attention, waiting for us to finally listen to its silent history. High above the Martian surface, the Mars Reconnaissance Orbiter endlessly circles a world painted in oxidized iron, charting the scars of a forgotten era. The scent of rust seems to linger even in the sterile clean rooms where its high-resolution cameras were built, preparing to map ancient riverbeds with astonishing precision. If we were to look closer at the winding valleys carved into the bedrock, we would see the undeniable ghost of flowing water. The orbiter's penetrating gaze captures the intricate networks of dried-up deltas and plunging canyons, proving this desiccated globe once harboured raging floods. It is a haunting cartography of ruin, tracing the veins of a planet that bled its oceans into the void billions of years ago. Surprisingly, the high-definition landscapes sent back to Earth are not merely scientific data, but breathtaking works of geological art. Sweeping dunes ripple across crater floors like waves frozen in time, their crests dusted with seasonal frost. As you let your shoulders drop and your breathing slow, imagine floating alongside this tireless sentinel, tracing the intricate patterns of a world suspended in eternal drought. Deep within the swirling dust storms that occasionally engulf the entire sphere, another robotic detective seeks to solve the ultimate planetary mystery. Probes deliberately dip into the tenuous upper fringes of the atmosphere, literally tasting the invisible gases as they bleed into space. By sniffing the escaping isotopes of hydrogen and oxygen, the spacecraft is uncovering exactly how this world lost its protective blanket and its life-giving water. This structure, bristling with sensitive spectrometers, flies through a constant barrage of solar wind that relentlessly strips away the planet's remaining air. Billions of years ago, a catastrophic failure of the global magnetic field allowed the sun to scour the atmosphere, transforming a blue haven into a global desert. The orbiter measures this ongoing theft molecule by molecule, quantifying the slow, tragic suffocation of an entire world. Picture the subtle crunch of dry, frozen soil that now blankets the surface, a direct consequence of this atmospheric vanishing act. Without enough air pressure to keep water liquid, the oceans boiled away or retreated deep underground, leaving behind a frozen, irradiated wasteland. The data streaming from orbit serves as a stark planetary cautionary tale, revealing how fragile the balance of a habitable world truly is. Decades before these modern orbiters arrived, humanity cast its first successful gaze upon the surface through the mechanical eyes of the Viking lander. Plunging through the thin alien sky, the heavy machine fired its retro rockets and touched down, capturing the first clear panoramic image from the ground. It revealed a desolate, rock-strewn landscape stretching to a hazy horizon, bathed in a strange, butterscotch-coloured light. If we were to look closer at those grainy historic photographs, we would sense the profound isolation of that early metallic pioneer. The scent of rust and the subtle crunch of dry, frozen soil were implied in every pixel of the scattered boulders and wind-sculpted dunes. It was the first time our species could virtually stand on another planet and look out across a silent, motionless alien plain. Surprisingly, the immediate environment around the landing site was devoid of any obvious macroscopic life or vegetation, a stark contrast to the wild imaginings of early science fiction. The robotic arm reached out to scoop up the reddish dirt, bringing the first physical pieces of the surface inside its automated laboratory for chemical analysis. Let your muscles relax deeper into your seat as you picture that lonely arm digging into the dust of a dead world under a pale, distant sun. Gliding through an atmosphere only 1% as dense as our own requires an extraordinary feat of aerodynamic engineering. A tiny helicopter, a marvel of lightweight carbon fibre and rapidly spinning blades, proved that powered, controlled flight is possible on another world. This tissue box-sized drone spun its rotors to hypersonic speeds, just to catch enough of the wispy air to lift itself off the ground. Notice the subtle crunch of dry, frozen soil beneath its delicate legs as it lands safely after a brief, autonomous aerial scouting mission. It navigates by taking rapid photographs of the ground below, recognizing rocks and craters to keep itself stable in the unpredictable winds. Every successful hop across the rugged terrain expands the boundaries of extraterrestrial exploration, opening up the skies of alien planets. Deep within the Flight Control Center on Earth, engineers wait anxiously for the delayed telemetry confirming the frail craft has survived another freezing night. The extreme cold threatens to crack its delicate electronics, yet the little helicopter repeatedly wakes up, warms its batteries, and takes to the thin air. It is a testament to perseverance, a mechanical dragonfly buzzing bravely over the dunes of an oxidized desert. Far below the soaring orbiters, a heavy nuclear-powered laboratory rolls slowly across the floor of an immense crater on 6 scarred aluminum wheels. The Curiosity rover pauses before an intriguing outcrop, raising its mast to fire a pulsing beam of concentrated light directly at the stone. It laser zaps rocks to vaporize tiny patches of their surface, reading the chemical history of a dried-up lake through the brilliant flash of plasma. This mobile chemist is searching for the foundational building blocks of life, grinding into the bedrock to analyze the ancient preserved sediments. The scent of rust is overpowering here, baked into the clay and sulfates that formed in liquid water long before the planet dried out. By tasting the vaporized dust, the rover reconstructs a time when freshwater rivers pooled into deep, calm lakes that could have supported microscopic organisms. If we were to look closer at the drill holes left behind, they form a connect-the-dots map of humanity's search for biological potential. Feel the gentle rhythm of your own breathing as you imagine the patient, methodical progression of this solitary explorer climbing the foothills of a central mountain. Each scraped rock and analysed pinch of soil whispers secrets of a warmer, wetter era locked away in the freezing sedimentary archive. While other machines roam the surface, a stationary geologist was sent to listen to the deep, hidden heartbeat of the planet. A lander gently placed an incredibly sensitive seismometer directly onto the regolith, shielding it from the wind to capture the faintest internal tremors. The subtle vibrations of subterranean quakes were carefully recorded, revealing a surprisingly active interior beneath the seemingly dead, cratered crust. Surprisingly, the planet rings like a bell when struck by meteorites, the seismic waves bouncing through the core and mantle to expose its internal architecture. The data collected by this patient listener proved that the red world is not completely frozen solid, but still possesses a warm, churning liquid core. These subterranean rumbles paint a picture of a world still slowly cooling and shrinking, cracking its outer shell as it ages. Picture the absolute stillness required for the instrument to detect ground movements smaller than the width of a single hydrogen atom. The subtle crunch of dry, frozen soil settling during these quakes was the only physical disturbance in an otherwise totally static landscape. The mission required perfect silence, allowing us to press our collective ear to the dirt and hear the geological groans of an alien sphere. Orbiting patiently above the swirling dust, another highly specialized satellite conducts a relentless hunt for a very specific, elusive chemical signature. The trace gas orbiter sniffs the alien air for faint traces of methane, a gas that is overwhelmingly produced by living organisms on our home world. Finding this volatile molecule could be the smoking gun proving that subterranean microbial life still clings to existence deep below the irradiated surface. This structure utilizes sophisticated solar occultation, looking through the edge of the atmosphere at sunrise and sunset to catch the shadows of rare molecules. The mystery deepens because the methane seems to appear in sudden localized plumes before mysteriously vanishing, defying our current atmospheric models. It is a cosmic game of hide and seek, with the orbiter acting as an ultra-sensitive bloodhound tracking an invisible scent. Deep within the scientific community, debates rage over whether these gaseous burps are the breath of hidden bacteria or simply the result of water reacting with subsurface rock. Allow your jaw to unclench and your mind to drift as you ponder the implications of finding even the simplest biological metabolism on a neighbouring world. The orbiter continues its silent circles, waiting for the atmosphere to exhale its greatest secret. At the extreme northern and southern latitudes, the planet wears brilliant white crowns of frozen water and dry ice that wax and wane with the orbital calendar. Every passing season brings dramatic changes to the polar ice caps, watched continuously by a fleet of robotic eyes in the sky. During the harsh winter, the atmosphere itself freezes out, depositing thick layers of carbon dioxide snow over the rusted terrain. If we were to look closer at the arrival of spring, we would witness bizarre otherworldly phenomena as the sun warms the translucent ice. Jets of dark dust erupt from below the surface, creating strange spider-like patterns across the polar dunes as trapped gas violently escapes. The scent of rust is buried deep beneath these shifting glaciers, locked away until the summer sun forces the dry ice to subliminate back into the sky. Surprisingly, the poles hold enough trapped water to blanket the entire planet in a shallow ocean if it were ever melted. These icy reservoirs are the most accessible remnants of the world's ancient hydrology, serving as vital resources for any future human visitors. The orbital sentinels document this frozen breath of the planet, recording the slow, rhythmic pulse of a global climate cycle. Touching down in the remains of an ancient river delta, our most advanced roving astrobiologist is currently undertaking a meticulous scavenger hunt. The newest rover carefully selects, drills and extracts pristine core samples of rock, sealing them in titanium tubes designed to withstand the harshest conditions. It is leaving them in small caches across the crater floor, preparing a priceless geological bounty for a future retrieval mission to eventually bring back home. This forward-thinking strategy marks the first leg of an unprecedented interplanetary relay race, linking the present explorers with machines yet to be built. As your body rests completely supported by your chair, consider the profound patience of a mission that will not see its ultimate conclusion for over a decade. The rover drops its metal treasures in the dust, trusting that humanity will one day return to collect them. Through the combined efforts of the orbiters, landers and rovers, a profound paradigm shift has occurred in our understanding of our planetary neighbour. What once appeared as a static, heavily cratered moonscape has been completely transformed into a narrative of dramatic environmental upheaval. Through the lenses of these probes, a seemingly dead world slowly reveals its highly dynamic, violently volcanic, and incredibly watery past. Deep within the data, we see the echoes of mega tsunamis that once crashed against the shores of a northern ocean, and volcanoes that dwarfed any mountains we know. The scent of rust is simply the final consequence of a vibrant, active history that was tragically cut short by the loss of its magnetic shield. By studying this desolate terrain, we learn the precarious nature of planetary habitability and the fleeting, delicate conditions required to sustain an atmosphere. If we were to look closer at the rusted horizon, we no longer see just a barren wasteland, but the magnificent ruins of a lost oasis. The robotic explorers have resurrected the ghost of a blue and green sphere, allowing us to witness the vibrant world it used to be. The dry, frozen soil is a planetary graveyard, holding the ultimate warning about the fragile environment we currently call home. Far beyond that fragile environment and its frozen planetary graveyard, the solar system gives way to realms of chaotic, crushing magnitude. The Galileo spacecraft spent over a decade orbiting the largest planet in our neighbourhood, mapping swirling storms and undiscovered moons. Yet, its 14-year mission ended not with a silent failure, but with a deliberate sacrificial dive directly into the atmosphere of the gas giant it studied. Recognizing the potential for microscopic Earth life to have survived inside its chassis, scientists realized they could not risk the aging probe eventually crashing into the pristine, icy moon Europa. To protect the hidden oceans of that fragile satellite from biological contamination, the orbiter was commanded to plunge to its own fiery destruction. The deafening roar of supersonic winds tearing through thick clouds welcomed the metallic explorer as it burned like a brilliant meteor. This final noble act ensured that if life ever blossoms in the dark waters of Europa, it will do so completely undisturbed by the remnants of our engineering. Another deliberate sacrifice echoed across the outer solar system years later, repeating this dramatic ritual of planetary protection. After spending an unprecedented 13 years mapping a different ringed giant, the Cassini spacecraft found its fuel reserves running dangerously low. To prevent an accidental collision with potentially habitable moons, mission controllers aimed the incredibly successful probe directly at Saturn. Plunging deep into the hydrogen atmosphere at unimaginable speeds, the delicate instruments fought to transmit data until the very last fraction of a second. Becoming a brilliant shooting star in the alien sky, the machine melted seamlessly into the swirling atmospheric bands it had spent its entire life observing. The deafening roar of supersonic winds tearing through thick clouds served as a chaotic symphony for its ultimate disintegration. It was a poetic conclusion to a historic voyage, blending the ashes of human curiosity permanently into the vast chemistry of the ringed world. Currently, a modern guardian skims the cloud tops of the largest planet, enduring conditions that would instantly destroy older generations of technology. The Juno probe sweeps incredibly close to Jupiter, executing long elliptical orbits that bring it grazing just above the violent upper atmosphere. It dives through the most hazardous radiation belts in the solar system, shielded by a heavy vault of pure titanium to protect its electronic brain. Sweeping incredibly close to the polar regions, its specialized sensors are busy measuring the intense, invisible magnetic fields that dominate the planet's immediate environment. These immense forces generate sprawling, dazzling auroras that constantly shift and shimmer, forming glowing halos far larger than our entire home world. Let your chest rise and fall steadily as you picture this heavily armoured craft plunging through rings of lethal radiation in total darkness. It is an intricate, perilous dance, threading the needle between safe space and the crushing embrace of a gravitational behemoth. Surprisingly, the most famous meteorological feature of this giant is far more than a simple surface blemish painted on the cloud tops. For centuries, astronomers have peered through telescopes to watch the Great Red Spot churn, assuming it was a relatively shallow anticyclone floating on the upper atmosphere. However, penetrating microwave instruments recently revealed that this monstrous storm extends hundreds of miles deep into the planet's interior. Deep within the swirling vortex, the storm roots itself in a lightless abyss, making it an atmospheric anomaly deeper than any ocean found on Earth. The staggering volume of this tempest could easily swallow our entire planet whole, tossing it around like a mere pebble in a raging river. The deafening roar of supersonic winds tearing through thick clouds is magnified infinitely inside this colossal, crimson hurricane. It is an engine of pure, unbridled kinetic energy, drawing its immense power from the hidden thermal heat radiating from the core of the gas giant. Long before the modern orbiters mapped these staggering depths, a much smaller Scout was dropped directly into the abyss on a one-way trip. Released by the main Galileo spacecraft, a heavy, cone-shaped descent module slammed into the Jovian atmosphere, deploying a parachute to slow its violent entry. Drifting downward through the turbulent layers, it became the very first human-made object to directly taste the chemistry of a gas giant. Descending into the rapidly increasing pressure, its instruments detected a bizarre and completely alien meteorological phenomenon occurring deep within the atmosphere. The probe recorded evidence of helium rain, a continuous drizzle of heavy liquid gas falling steadily through the vast hydrogen-rich skies. The deafening roar of supersonic winds tearing through thick clouds surrounded the tiny descending capsule as the ambient temperature began to skyrocket. Ultimately, the tremendous heat and crushing compression vaporized the brave little scout, but not before it transmitted a treasure trove of impossible atmospheric data back to the heavens. Picture the absolute chaos of a planetary ring system, a structure that appears so perfectly solid and serene when viewed from a vast distance. Over a decade of close observation by Cassini revealed these iconic bands are not quiet disks but deeply dynamic, shifting rivers of ice and shattered rock. The rings are in a constant state of turbulent collision, forming towering vertical waves and intricate braided structures driven by the gravity of passing shepherd moons. Allow your heavy limbs to sink completely into your cushions as you imagine millions of icy fragments tumbling silently in the dark vacuum of space. These shimmering particles, ranging in size from tiny grains of sand to massive mountains, orbit the gas giant in a surprisingly delicate, ever-changing balance. The deafening roar of supersonic winds tearing through thick clouds on the planet below does not reach this orbital ballet, yet the rings remain inextricably bound to the chaotic weather systems. The spacecraft dance precisely through these gaps, proving that the rings are an actively evolving temporary masterpiece of celestial mechanics. This metallic explorer, Juno, relies on an unprecedented method to harvest the energy required to survive in the incredibly dim reaches of the outer solar system. Previous missions venturing this far from the warming rays of the sun were forced to rely on decaying nuclear isotopes for their electrical power. Instead, this ambitious orbiter uses 3 massive sprawling solar panels, each the size of a professional basketball court, to catch the vanishingly faint light. Spanning an enormous distance, these intricate wings are covered in thousands of highly efficient individual cells designed specifically to operate in near-total darkness. At this incredible distance, sunlight is 25 times weaker than it is back on Earth, providing just barely enough illumination to keep the critical systems from freezing entirely. If we were to look closer at the delicate engineering of these vast arrays, we would see a marvel of structural design balancing mass and surface area. They spin slowly like the blades of a colossal silent windmill, constantly straining to harvest a meagre trickle of photons from the distant pale star. Deep beneath the cloud tops of these massive giants, the fundamental laws of chemistry and physics begin to twist into entirely unrecognizable forms. As you plunge thousands of miles past the upper atmosphere, the sheer weight of the overlying gas creates an environment of absolutely crushing, unimaginable pressure. The forces become so incredibly extreme that ordinary hydrogen gas is forcefully stripped of its normal atomic structure. The unimaginable weight forces the molecules into a miraculous phase transition, transforming the buoyant gas into a churning, electrically conductive ocean of liquid metal. This bizarre, exotic state of matter behaves more like liquid mercury than a breathable gas, forming an endless, lightless sea that wraps around the rocky core. This highly conductive fluid is the hidden dynamo driving the entire planetary system, generating the massive magnetic fields that stretch out into the vacuum of space. The deafening roar of supersonic winds tearing through thick clouds is merely the surface expression of this violent metallic heart beating in the deep dark. Notice how the weather systems on these colossal behemoths operate on a staggering timescale that completely humbles our brief human lifespans. Cyclones, anticyclones, and high-altitude jet streams discovered by the earliest astronomers peering through primitive glass lenses are still raging today. As probes study these massive planets, they find violent weather patterns that have churned for centuries without showing any discernible signs of slowing down. Take a slow, deep breath in, feeling your pulse calm, while envisioning these eternal hurricanes spinning ceaselessly in the Jovian night. Unlike terrestrial storms that quickly lose their momentum when they drift over land, these deep-rooted atmospheric beasts have no solid surface to break their ferocious energy. They are perpetual engines of fluid dynamics, feeding off the internal heat of the planet and absorbing smaller storms to maintain their terrifying momentum. The deafening roar of supersonic winds tearing through thick clouds is the eternal, unbroken soundtrack of a world that has never known a peaceful, quiet day. The staggering mass of the solar system's king exerts a gravitational dominance so profound that it bends the very trajectory of its robotic observer. Every time Juno completes an elliptical circuit and swoops in for a daring low-altitude pass, it must reckon with the crushing pull of the gas giant. The gravitational pull is so immensely strong, it actually alters the physical shape of the probe's orbit during every single close approach. During every maneuver, the immense gravity accelerates the spacecraft to mind-bending speeds, dragging it slightly off its predicted mathematical path. Mission navigators must constantly calculate these subtle orbital warps, using the precise deviations to map the uneven distribution of mass hidden deep inside the planet. It is a breathtaking, high-stakes cosmic tug-of-war between the delicate ingenuity of human engineering and the raw, unbridled power of celestial mechanics. The deafening roar of supersonic winds tearing through thick clouds serves as a silent threat just below the spacecraft, a constant reminder of the abyss waiting to claim it. Deep within the plume-shadowed canyons of the Saturnian system, the abyss does not just wait. It breathes. Beneath the gleaming, frozen crust of the tiny moon Enceladus, a hidden world of liquid water struggles against the crushing pressure of the ice. The crackling sound of fracturing ice over a dark, abyssal sea echoes through the subterranean silence as massive fissures tear open in the South Polar region. This structure, a crystalline shell of incredible purity, acts as a pressurized lid on a vast global reservoir. Surprisingly, the universe reveals its secrets through violent exhales, as Cassini discovered titanic geysers blasting water vapor and ice crystals hundreds of miles into the cold vacuum. The spacecraft performed a breathtakingly close flyby, steering its instruments directly through the freezing mist to sample the chemical signature of the deep. If we were to look closer at the microscopic grains captured during that high-speed transit, we would find complex organic molecules and salts hidden within the frozen droplets. Notice the rhythmic pulse of your own breath as you envision these colossal white fountains silhouetted against the golden glow of Saturn's rings. Cassini's discovery transformed our understanding of Enceladus from a cold, dead ball of ice into one of the most promising biological targets in the cosmos. If we were to look closer at the moon Europa, we would find a surface so smooth it resembles a cracked eggshell composed of polished crystal. While its exterior is a blindingly bright expanse of frozen water, the Galileo spacecraft sensed something profound hiding in the depths. By measuring the way Jupiter's massive magnetic field was warped as it swept past the moon, the probe detected a hidden global conductor. The crackling sound of fracturing ice over a dark abyssal sea defines the internal life of this Jovian satellite. This magnetic evidence suggests that a vast salty ocean containing more water than all of Earth's seas combined is locked beneath the icy exterior. The ocean is kept warm by the same tidal flexing that powers the volcanoes of neighbouring moons, creating a perpetual source of heat. The surface is crisscrossed by dark reddish lines, where the interior ocean has welled up and frozen into the gaps. These scars are a testament to the constant motion of the ice shell floating atop the liquid deep. Deep within the scientific data, we see a world where the abyss is not a void, but a dark, pressurized cradle of potential. Picture the absolute darkness of that subterranean sea, where no sunlight has ever penetrated in billions of years. Despite this eternal night, the presence of salt and liquid water makes it one of the most likely places to find extraterrestrial biology. As your body rests in perfect stillness, let your mind sink beneath the ice into the silent currents of Europa's hidden world. Surprisingly, the Moon Titan presents a landscape so eerily familiar that it feels like a distorted reflection of our own home. When the Huygens probe detached from its parent ship and plunged into the thick orange atmosphere, it found a world of rivers, coastlines, and islands. However, the liquid carving these features is not water, but frigid methane and ethane under a crushing atmospheric pressure. If we were to look closer at the landing site, the probe settled onto a squishy surface that felt like wet sand or frozen clay. The crackling sound of fracturing ice over a dark abyssal sea is replaced here by the soft patter of hydrocarbon rain falling from a hazy sky. Giant dark dunes of organic soot stretch across the equatorial regions, sculpted by the slow, thick winds of the massive moon. The landscape is a treasure trove of exotic chemistry, where frozen water ice acts as the hard bedrock and liquid gas behaves like water. It is a place where mountains are made of ice, and the soil is composed of complex polymers that have drifted down from the upper atmosphere. Notice how the ground beneath you remains firm while you imagine the soft, alien give of Titan's methane-soaked plains. This structure, the tiny moon Mimas, orbits Saturn with a distinctive and haunting silhouette that has captured the human imagination since it was first photographed up close. Dominating its surface is a truly colossal impact feature known as the Herschel crater, which spans nearly 1/3 of the moon's entire diameter. This massive depression, with its towering central peak and steep walls, gives the satellite a striking resemblance to a familiar science fiction space station. If we were to look closer at the physics of the collision that created this crater, we would realize that Mimas was nearly shattered into pieces by the force. The shockwaves from the impact traveled entirely through the moon's body, leaving visible fractures on the opposite side of the globe. It is a world of extreme contrast, where the crater's deep shadow perpetually hides a landscape of ancient pulverized rock. The crackling sound of fracturing ice over a dark abyssal sea might be a distant memory for this moon, which appears to be a solid, frozen block of water ice. Despite its small size and seemingly inert nature, the thermal maps provided by Cassini revealed a strange heat distribution on the surface. The sheer survival of this moon, after such a devastating impact, remains one of the great visual wonders of the Saturnian system. Deep within the impenetrable orange shroud of Titan, the Cassini spacecraft used its powerful radar eyes to strip away the haze and map the hidden terrain. What it found was a rugged world of dramatic topography, including soaring mountain ranges that rise thousands of feet into the thick air. Surprisingly, the universe has created these peaks not from granite or basalt, but from water ice frozen into a state as hard as terrestrial stone. The crackling sound of fracturing ice over a dark abyssal sea echoes in the geological history of these mountains, which are often coated in a dark organic snow. These peaks were likely formed by tectonic forces similar to those on Earth, as the moon's crust is pushed and pulled by the immense gravity of Saturn. The radar images show steep ridges and deep valleys, suggesting a world that has been geologically active for aeons. Picture the view from one of these icy summits, looking out over a horizon perpetually obscured by a thick amber mist. The air is so dense that if a human were to stand on these peaks with artificial wings, they could easily fly by simply flapping their arms. As your muscles relax and your weight settles into your seat, feel the vast, cold stillness of these lightless frozen peaks. Notice the intricate patterns etched into the surface of Ganymede, the largest moon in our entire solar system and the only one to possess its own magnetic field. Its crust is a complex tapestry of dark, ancient terrain and bright, younger regions filled with vast grooves and ridges. These geometric scars suggest a violent and complicated geological history, driven by the intense tidal forces of Jupiter. The crackling sound of fracturing ice over a dark abyssal sea is the primary sculptor of this massive metallic cored world. As the moon orbits the gas giant, the gravitational tugging causes the ice shell to flex, generating internal heat and tearing the surface apart in long parallel lines. These features indicate that Ganymede was once much more active than it appears today, with liquid water potentially welling up to fill the gaps. If we were to look closer at the grooves, we would see evidence of massive tectonic plates of ice that once slid and collided like those on Earth. Deep within the moon's interior, a layered ocean of salt water may still exist, sandwiched between different phases of high-pressure ice. This world is a planetary-sized archive of the tidal forces that rule the Jovian system. If we were to look closer at these hidden oceans, far beneath the reach of any sunlight, a different kind of energy source may be fueling a hidden biosphere. The discovery of silica particles and molecular hydrogen in the plumes of icy moons suggests that the rocky seafloors are in direct contact with hot circulating water. Surprisingly, the universe may have created hydrothermal vents on these distant moons that are nearly identical to the life-sustaining chimneys found at the bottom of Earth's oceans. The crackling sound of fracturing ice over a dark, abyssal sea is a distant murmur compared to the hissing of mineral-rich water erupting from the seafloor. These vents provide the necessary warmth and complex chemistry required for the building blocks of life to assemble and thrive. In these dark, pressurized depths, life would not depend on photosynthesis, but on chemosynthesis, drawing its strength from the planet's internal heat. Surprisingly, the universe has prepared a chemical laboratory of incredible potential within these remote subterranean depths. This realization has turned the dark oceans of the outer solar system into the primary focus of our search for life beyond Earth. Let the warmth of this thought spread through your body as you envision the glowing, life-giving heat in the cold, dark deep. Surprisingly, the moon Callisto presents a face that is a perfect, unedited record of the solar system's most violent and ancient history. It is the most heavily cratered object in our neighbourhood, with its surface so saturated with impact scars that every new meteor strike simply destroys an older one. Because the moon has no known geological activity to erase these marks, it remains a silent, icy archive of the early solar system. The crackling sound of fracturing ice over a dark abyssal sea is rarely heard on this world, which has remained largely unchanged for billions of years. Its surface is a dark, dusty crust of ice and rock, featuring massive multi-ring impact basins that look like ripples frozen in a pond. These structures tell the story of colossal collisions that occurred when the solar system was still a chaotic shooting gallery of debris. This structure is a time capsule, preserving the scars of every asteroid and comet that has crossed its path since the dawn of time. Unlike its neighbours, Callisto chose a path of stillness, avoiding the tidal heating that keeps Europa and Ganymede geologically alive. As you breathe deeply and feel your body resting in quiet stillness, imagine the billions of years of peace that have settled over this cratered, icy giant. This structure, the ethereal and expansive E-ring of Saturn, owes its entire existence to the constant activity of a single, tiny moon. As Enceladus orbits within this diffuse halo of light, its south polar geysers act as a tireless fountain, actively feeding the ring with fresh material. The crackling sound of fracturing ice over a dark, abyssal sea is the engine that drives this planetary-scale phenomenon. If we were to look closer at the E-ring, we would see that it is composed primarily of microscopic particles of water ice and dust ejected from the moon's interior. Most of this material escapes the moon's weak gravity and enters its own orbit around Saturn, creating a ghostly wide band of frozen mist. The ring is widest and densest exactly where Enceladus travels, marking the moon's path like a silver trail of frozen breath in the dark. Surprisingly, the universe has created a system where a moon essentially paints its own environment onto the canvas of the gas giant. This interaction allows us to study the chemistry of Enceladus's hidden ocean without ever having to land on its surface, simply by flying through the ring itself. Notice the vast, shimmering scale of this ice-fed halo as you imagine the tiny moon at its heart, constantly replenishing the void. This shift in our understanding of what makes a world habitable has been forever altered by the lightless reaches of the outer solar system. For decades, we believed that life required the direct warmth of a star in a surface ocean exposed to the open air. However, the exploration of these icy moons has proved that oceans can exist and thrive far beyond the traditional sun-soaked Goldilocks zone. The crackling sound of fracturing ice over a dark, abyssal sea has become a new siren song for the future of space exploration. We now realise that tidal energy and chemical reactions at the seafloor are more than enough to sustain liquid water and potentially even complex life. This revelation suggests that every gas giant in the galaxy might harbour a family of watery hidden worlds beneath their icy shells. If we were to look closer at the implications, we would see that the solar system is much wetter and more hospitable than we ever dared to imagine. The abyss is no longer a place of empty desolation, but a dark, pressurized frontier filled with the ingredients of creation. Let this sense of a vast living cosmos fill your mind as you drift into a state of deep, peaceful wonder. This sense of peaceful wonder finds its most daring expression in the pursuit of the wanderers who have travelled from the farthest reaches of the dark. For 10 years, the Rosetta spacecraft executed a silent, high-stakes chase through the void, matching its pace with the tumbling, two-lobed form of Comet 67P/Churyumov-Gerasimenko. It accomplished the near impossible by becoming the first machine to enter orbit around a comet, settling into a delicate gravitational embrace with a mountain of ice and stone. Deep within the mission's final phase, the tension reached a crescendo as the tiny Philae lander was released for its descent toward the craggy alien surface. Despite its harpoons failing to fire, the lander touched down, bounced twice, and eventually came to rest in the shadow of a towering cliff. The gritty texture of ancient primordial dust clinging to a solar panel marked its arrival on a world that has remained largely unchanged for billions of years. Surprisingly, the universe rewarded this tenacity with a treasure trove of data from the comet's rugged exterior. We watched as the sun's warmth began to vaporize the comet's frozen heart, sending plumes of gas and dust screaming into the vacuum. As you lie still, imagine the soft thud of those mechanical feet meeting the alien soil for the first time in human history. Approaching the charcoal-black silhouette of the asteroid Bennu, a different kind of predator prepared to make its mark on the cosmic archive. The OSIRIS-REx spacecraft spent months mapping every boulder and crevice of this ancient rubble pile, searching for a safe place to touch the sky. It performed a daring touch-and-go maneuver, descending toward the surface with the grace of a hummingbird to snatch a handful of pristine carbon-rich rock. This structure, a robotic arm known as the tagsum, pressed into the surface for only a few brief seconds, but the encounter was far more violent than anyone had anticipated. The asteroid's surface acted more like a fluid than solid ground, splashing upward as the probe's nitrogen gas blast stirred the ancient regolith. The gritty texture of ancient primordial dust clinging to a solar panel told the story of this brief, chaotic contact. If we were to look closer at the sample captured within the collection head, we would see fragments of a world that predates the Earth itself. These pebbles are messengers from a time when the solar system was just a swirling disk of gas and debris. Picture the weight of your body settling into your chair, grounded on a planet that was once built from exactly this kind of stardust. Deep within the main asteroid belt, a tireless explorer named Dawn utilized the blue glow of an ion drive to visit two completely different worlds in a single voyage. It first settled into orbit around Vesta, a dry, battered protoplanet that looks like a giant half-eaten potato in the sky. Vesta is a world of basaltic rock and towering mountains, representing the rocky building blocks of the inner solar system. Transitioning away from that scorched landscape, the spacecraft drifted outward to meet the icy dwarf planet Ceres, the largest object in the belt. This structure, Ceres, revealed itself to be a hidden world of frozen water and mysterious chemistry, fundamentally different from its rocky neighbour. The gritty texture of ancient primordial dust clinging to a solar panel was the only evidence of the millions of miles travelled between these two disparate siblings. Surprisingly, the universe has packed such diversity into a relatively narrow band of space between Mars and Jupiter. One world is a dry volcanic relic, while the other is a frigid watery sphere that might once have harboured a subterranean ocean. As you breathe slowly and deeply, Imagine the silent transition from the jagged peaks of Vesta to the smooth, white-flecked plains of Ceres. Surprisingly, the universe possesses a sensory profile that is often far more pungent and visceral than our sterile photographs would suggest. When the Rosetta spacecraft analysed the gas cloud surrounding its comet, it discovered a chemical cocktail that would be overwhelmingly offensive to a human nose. The instruments detected a sharp, biting mixture of ammonia, hydrogen sulfide and formaldehyde, creating a stench reminiscent of rotten eggs and stable floors. This aromatic profile was further complicated by the presence of hydrogen cyanide, which carries the distinct bitter scent of almonds. It is a strange paradox that a celestial object of such haunting beauty would smell like a toxic, decaying laboratory. The gritty texture of ancient primordial dust clinging to a solar panel acted as a catalyst for these chemical reactions, releasing the smells as the sun's rays warmed the ice. If we were to look closer at the chemical signatures, we would realise these offensive gases are the very precursors to life. They are the raw materials that, when delivered to a young Earth, may have ignited the first sparks of biological activity. Notice the clean, neutral air in your own room as you contrast it with the toxic, ancient perfume of a travelling comet. The Hayabusa 2 mission set out to do more than just observe an asteroid. It sought to physically wound one to reveal its hidden secrets. Orbiting the diamond-shaped asteroid Ryugu, the spacecraft deployed a small carry-on impactor, which fired a massive copper projectile into the surface at high speed. This deliberate explosion was designed to excavate a fresh crater, clearing away the sun-bleached exterior to expose the pristine material below. This structure, the resulting artificial crater, allowed the probe to descend and collect samples that had been shielded from space radiation for millions of years. The gritty texture of ancient primordial dust clinging to a solar panel was a direct byproduct of the debris cloud kicked up by the impact. It was a bold, surgical strike against a celestial body, executed with incredible robotic precision from millions of miles away. Surprisingly, the universe showed us that Ryugu is essentially a loose collection of boulders held together by nothing but their own weak gravity. The impact behaved differently than it would have on a solid rock, proving that these rubble pile asteroids are far more porous and fragile than they appear. Let your mind drift to the silent, slow-motion explosion of dust as the copper meets the dark, ancient stone. As the deep impact probe hurtled toward Comet Tempel 1, it carried a massive copper impactor destined for a spectacular high-speed collision. On the 4th of July, the world watched as the refrigerator-sized block of metal slammed into the comet's icy heart, releasing the energy of several tons of dynamite. The resulting flash was so bright it was captured by telescopes across the globe, and even by those orbiting in deep space. This structure, a massive crater excavated by the force of the strike, allowed the flyby spacecraft to peer into the comet's interior for the first time. It revealed a hidden world of fine, powdery dust and pockets of frozen gases that had been locked away since the formation of the Sun. The gritty texture of ancient primordial dust clinging to a solar panel was the only physical souvenir for the spacecraft as it sailed through the debris cloud. Notice how the comet's surface seemed to behave like a fine, dry powder rather than a solid block of hard ice. The experiment proved that comets are not just dirty snowballs, but complex structures of fragile, porous materials. As you feel the steady support of the ground beneath you, imagine the brief, violent spark of light in the total darkness of the outer solar system. Deep within the shadows of the Akata crater on Ceres, a series of brilliant luminous spots defied every expectation of the scientific team. As the Dawn spacecraft approached, these white patches shone with such intensity against the dark terrain that they were initially mistaken for exposed water ice. However, detailed analysis revealed they are actually massive deposits of sodium carbonate, a type of salt often found in Earth's hydrothermal systems. Surprisingly, the universe has hidden a briny heart inside this dwarf planet, which periodically exhales salty water through its cracked crust. The spots are the remnants of a briny liquid that bubbled up from a subsurface reservoir, leaving behind a crust of salt as the water evaporated into space. The gritty texture of ancient primordial dust clinging to a solar panel is a stark contrast to the brilliant crystalline purity of these salty scars. If we were to look closer at the floor of the crater, we would see evidence of relatively recent geological activity on a world once thought to be dead. This suggests that Ceres may still harbour enough internal heat to maintain pockets of liquid water deep underground. Picture the ghostly white glow of these salt flats standing out against the charcoal plains as you relax your jaw and soften your gaze. Gliding past the peanut-shaped asteroid Itokawa, the first Hayabusa probe became a legend of perseverance despite suffering through a series of catastrophic technical failures. Its landing system malfunctioned, its thrusters leaked, and it spent weeks drifting aimlessly in space before the team on Earth could regain control. Against all odds, the mission managed to limp back to Earth, carrying a sealed capsule that many feared would be empty. This structure, the sample return capsule, was found to contain over 1,500 microscopic grains of asteroid dust, each one a precious fragment of a distant world. The gritty texture of ancient primordial dust clinging to a solar panel was the only companion for the probe during its long, silent struggle to return home. It was the first time humanity had ever successfully retrieved material from the surface of an asteroid and brought it back to our own soil. Surprisingly, the universe reveals its greatest secrets not just through flawless success, but through the grit and determination of our machines. These tiny grains provided the first direct link between the meteorites we find on Earth and the asteroids we see in the sky. Notice the quiet strength in your own body as you contemplate the incredible journey of this small, battered explorer. If we were to look closer at the structural integrity of many small asteroids, we would find they are not solid monoliths of rock at all. Instead, many of them are rubble piles, loose collections of boulders, pebbles, and dust held together by nothing more than the vanishingly weak pull of their own gravity. They are essentially cosmic junk heaps, with vast empty spaces making up nearly half of their total volume. Surprisingly, the universe has created objects that are so fragile that a strong push from a human hand could potentially tear them apart. This high porosity means that they respond to impacts and gravitational pulls in ways that are entirely counterintuitive to our experience on Earth. The gritty texture of ancient primordial dust clinging to a solar panel is the only thing providing a sense of cohesion to these tumbling clouds of debris. This structure, a delicate balance of mass and motion, makes navigating around these asteroids an incredible challenge for our spacecraft. They are essentially piles of sand floating in a vacuum, where a single misplaced thruster blast could send boulders flying in every direction. As you sink deeper into your seat, imagine the strange, weightless instability of a world that could crumble at the slightest touch. By capturing these ancient fragments from the deep dark, our space probes are delivering physical time capsules from the very dawn of our solar system. These comets and asteroids are the pristine leftovers of the planetary construction process, preserved in the cold storage of the void for billions of years. They contain the original recipe for our world, including the water and organic molecules that may have seeded the first life on Earth. Deep within the chemical structures of these rocks, we can read the history of the sun's birth and the violent collisions that shaped the planets. The gritty texture of ancient primordial dust clinging to a solar panel is the ultimate bridge between our modern technology and our most ancient origins. Each mission is a reach back in time, allowing us to touch the raw materials from which we were once made. If we were to look closer at these samples, we would see that we are not separate from the cosmos, but intimately connected to its earliest moments. These fragments are the missing pieces of our own story, found drifting in the silent, sun-drenched reaches of the asteroid belt. Let a final wave of peaceful wonder wash over you, as you realize that by chasing these rocks, we are truly chasing ourselves. This persistent pursuit of our own origins inevitably leads us back toward the heart of the light, where that peaceful wonder is tempered by the blinding, intense glare of sunlight reflecting off protective thermal shields. The Parker Solar Probe executes a daring high-speed dive directly into the Sun's corona, the outer atmosphere of our star. It endures a bombardment of radiation and heat that would instantly melt ordinary metals protected by a specialized carbon composite shield. This shield, only a few inches thick, allows the instruments behind it to operate at a comfortable room temperature, while the face of the craft is seared by thousands of degrees. Within this lightless shadow, the probe captures the first direct samples of the solar atmosphere, touching the very plasma that creates our space environment. It moves at speeds exceeding hundreds of thousands of miles per hour, making it the fastest object ever crafted by human hands. Imagine the absolute stillness required to maintain this trajectory while being buffeted by the intense pressure of solar photons. The spacecraft must autonomously adjust its orientation with extreme precision to ensure the delicate sensors never peek out from behind the protective shadow. Small thrusters fire with microscopic accuracy to counteract the push of the light, keeping the shield perfectly aligned with the sun's center. As you feel the weight of your body resting securely in place, consider the bravery of this mechanical scout flying through the literal breath of a star. It records the vibrations of the solar plasma and the snapping of magnetic field lines as they tangle and release. Every byte of data sent back to Earth is a hard-won victory from the front lines of our star's violent edge. Surprisingly, the closest planet to the Sun hides a frozen secret within its most lightless and ancient depths. Orbiting the battered, scorched surface of Mercury, the Messenger spacecraft peered into the permanent shadows of craters at the poles where the Sun never reaches. There, it discovered vast deposits of water ice and dark organic materials, preserved for aeons in the deep freeze of the planet's dark side. These cold traps occur because Mercury has almost no axial tilt, meaning the floors of its deepest polar craters are perpetually shielded from the solar furnace. The ice likely arrived via comet impacts over billions of years, remaining stable because the temperatures in the shadows never rise above a freezing threshold. The blinding, intense glare of sunlight reflecting off protective thermal shields on the craft's sunward side is a sharp contrast to the absolute blackness of these ice-filled pits. If we were to look closer at the data, we would find that the ice is often covered by a layer of dark, carbon-rich material that acts as an insulator. This discovery suggests that the building blocks of life are scattered even in the most inhospitable and scorched corners of our solar system. Scientists were stunned to find such a wealth of volatile materials on a world that is otherwise a baked, iron-rich wasteland. Descending through the thick acidic clouds of our sister planet, a series of brave Soviet landers undertook what was essentially a suicidal mission to the most hostile surface in the solar system. The Venera landers were engineered to survive for mere minutes or hours, just long enough to capture and transmit the only photographs we possess of a cracked orange-hued volcanic surface. The blinding, intense glare of sunlight reflecting off protective thermal shields was quickly replaced by the oppressive, dim orange glow of a world trapped under a runaway greenhouse effect. The landing was a harrowing struggle against a dense atmosphere of carbon dioxide and rain made of concentrated sulfuric acid. Once on the ground, the craft had to operate in a lightless, heavy air that distorted the view of the surrounding basaltic rocks and sharp outcroppings. Heat seeped through the thick titanium hulls, slowly cooking the delicate electronics despite the best efforts of the engineers to keep them cool. Notice how your own environment is characterized by a breathable, light atmosphere, a sharp contrast to the crushing weight of the Venusian sky. These metallic pioneers managed to record the wind speeds and soil composition of this alien hellscape before the heat inevitably fried their internal circuits. The sensors tasted the air and found a world dominated by volcanic gases and a crushing pressure that would flatten a human in an instant. Their legacy remains a set of grainy, historic images that represent the first and only time we've seen the ground of our closest neighbour. These photos reveal a landscape of sharp rocks and flat plains, all bathed in an eerie, shadowless light that filters through the thick cloud deck. They are haunting postcards from a world that took everything we built and reduced it to slag in a matter of hours. This structure, the Parker probe, does not fly a simple straight path but instead performs a complex celestial dance with the planet Venus to reach its destination. By swinging close to the shrouded world, the probe uses Venus's gravity as a cosmic brake to gradually shrink its orbit and fall closer to the Sun than any human-made object in history. Each pass brings the craft into a tighter, more intimate embrace with the star, pushing the boundaries of how deep we can venture into the solar furnace. These gravity assists are timed with incredible precision, requiring the craft to pass through the upper fringes of the Venusian atmosphere at exactly the right angle. During these flybys, the instruments are briefly turned toward the clouded planet, capturing data on the lightning and magnetic phenomena occurring in the thick haze. The blinding, intense glare of sunlight reflecting off protective thermal shields is momentarily softened as the craft dips into the planet's shadow. Surprisingly, the universe allows us to use the mass of one world to change the speed and direction of our travel toward another without using a single drop of fuel. This orbital mechanics masterpiece ensures that we can reach the Sun's corona while maintaining enough control to stay in orbit for years of study. Every assist brings the craft's closest point to the Sun even nearer, increasing the speed and the heat the craft must endure. As you breathe slowly and feel the air around you, imagine the silent, sweeping arc of the probe as it uses a whole planet as a slingshot. It is a moment of quiet grace in a mission defined by extreme speed and violent radiation. The spacecraft glides past the amber clouds of Venus, gathering momentum for its next heroic dive into the fire. Since the surface of Venus is perpetually hidden beneath an impenetrable blanket of sulfuric acid clouds, we had to find a creative way to see through the haze. The Magellan spacecraft utilized powerful radar pulses to pierce this dense atmosphere, mapping the hidden topography of the entire planet with incredible clarity. It revealed a world dominated by towering volcanoes, vast lava plains, and intricate tectonic ridges, a landscape sculpted by a heat so intense it defies imagination. The radar data allowed scientists to reconstruct a three-dimensional view of mountains that rival the highest peaks on Earth and vast channels carved by flowing molten rock. These maps showed a world without plate tectonics, where the heat from the interior builds up until the entire crust occasionally melts and resets itself. The blinding, intense glare of sunlight reflecting off protective thermal shields was the only light the spacecraft knew as it worked tirelessly in orbit. Surprisingly, the universe has created a world that appears to have been completely resurfaced by a global volcanic event several 100 million years ago. This discovery suggests that Venus has a very different geological pulse compared to the steady shifting of Earth's continents. The probe revealed thousands of small volcanoes scattered across the plains, evidence of a world that is cooling in a very different way than our own. Let your shoulders relax as you contemplate the vast hidden plains of our sister world, mapped in exquisite detail by a machine that never once touched the ground. You can almost feel the dry, stagnant heat of those radar-imaged valleys, where no water has flowed for billions of years. It is a triumph of remote sensing, turning a blind, shrouded world into a masterpiece of digital cartography. This structure, the solar atmosphere, is home to explosive events and magnetic waves that launch particles into the void at incredible velocities. The probe's measurements indicate that small-scale magnetic reversals and tiny flares may be the engines driving this localized intense heating. The blinding, intense glare of sunlight reflecting off protective thermal shields is the physical reality the craft must endure to witness these invisible, violent processes. Picture the immense energy required to heat a gas to such temperatures that it begins to glow with X-rays and ultraviolet light. Scientists have struggled for decades to explain this phenomenon, and the answers are finally being teased out of the solar wind itself. The craft records switchbacks in the magnetic field, moments where the solar wind suddenly doubles back on itself in a violent snap. Feel the steady rhythm of your heartbeat and the warmth of your own skin, reflecting on the fact that we are finally touching the fire that governs our entire solar system. This mission is bringing us closer to understanding the fundamental nature of the stars that fill our sky. We are no longer just observers from a distance. We are participants in the discovery of the sun's most guarded secrets. If we were to look closer at the smallest planet, we would find a core that is unexpectedly massive and a magnetic field that should not exist for a world its size. The Bepi-Colombo mission is currently on its multi-year journey, prepared to deploy 2 separate orbiters to study Mercury's odd magnetic field and its interaction with the nearby Sun. This dual approach will allow scientists to map the planet's internal structure and its scorched exterior simultaneously from 2 different perspectives. One orbiter will focus on the planet's surface and composition, while the other will sit further back to monitor the magnetic envelope that shields the planet from the solar wind. The blinding, intense glare of sunlight reflecting off protective thermal shields is a constant challenge for this mission, requiring the craft to be wrapped in specialized white ceramic insulation. These materials are designed to reflect nearly all the incoming solar radiation to keep the internal computers from failing. Notice how the mission uses a specialized sun shield to protect the second orbiter during the long transit across the inner solar system. This complex partnership between international space agencies represents a global effort to understand how the closest planets formed in the chaotic early days of our star. The spacecraft must also contend with the immense gravitational pull of the Sun, which constantly tries to pull it into a fatal plunge. As you rest in the quiet of your room, imagine these 2 metallic companions preparing to split apart and begin their long, synchronized watch over the iron planet. They will dance around the scorched world, tracing the invisible lines of force that emanate from its mysterious core. It is a mission of extreme patience, requiring years of careful maneuvers to finally reach its permanent home. If we were to look closer at the rocks, we would see they are composed of basaltic lavas that have been chemically weathered by the acidic and hot atmosphere. It is a world of stagnant, heavy beauty, where the horizon is distorted by the thick air, and the sky is a permanent glowing shade of deep orange. No moon or stars are ever visible from the ground, only the thick yellowish ceiling of clouds that traps the heat like a lid on a pot. Take a moment to appreciate the cool, thin air you breathe, so unlike the crushing metallic weight of the Venusian surface. Imagine the silence of that world, broken only by the low, heavy groan of the wind pushing through the supercritical air. It is a world that has turned itself inside out, a sister to Earth that took a very different and much hotter path. Sweeping through the invisible and violent streams of the solar wind, the Helios probes were the first to venture deep into the inner solar system to measure the sun's breath. They tracked the constant flow of charged particles, protons and electrons, that stream away from the star and wash over every planet in the system. These observations provided our first real understanding of how space weather can interact with planetary atmospheres and our modern electronic technology. The probes travelled in highly elliptical orbits, repeatedly diving toward the Sun before swinging back out toward the orbit of Earth. The blinding, intense glare of sunlight reflecting off protective thermal shields was a constant companion as they recorded the density, temperature and speed of the solar plasma. These missions proved that the space between the planets is not empty, but filled with a dynamic and ever-changing wind of energy. Surprisingly, the universe is connected by these invisible threads of magnetism and light that link the Sun to the furthest reaches of the heliosphere. The Helios probes laid the foundation for all modern solar science, showing us that our star is a restless, active heart that beats with a rhythm of 11-year cycles. They measured the shock waves that ripple through the solar wind during massive solar flares, showing how the star can impact our entire cosmic neighbourhood. As your body rests in a state of deep calm, imagine the sun's wind rushing past you at hundreds of miles per second, invisible but ever present. It is a celestial tide that ebbs and flows, carrying the influence of the sun out to the very edge of our solar system. These early probes were the first to chart this invisible ocean, proving that we live within the atmosphere of a star. These inner system explorers represent the absolute pinnacle of human engineering, designed to survive the most extreme thermal environments ever encountered by our species. To function in the blinding, intense glare of sunlight reflecting off protective thermal shields, they use exotic materials like sapphire, niobium, and specialized white ceramic coatings. They are the ultimate survivors, robotic scouts that have proven we can reach out and touch the very fire that sustains our life. Each component, from the smallest wire to the largest antenna, must be tested to withstand the brutal vibration of launch and the subsequent searing heat of the inner solar system. The spacecraft are designed to be almost entirely autonomous, capable of making split-second decisions to protect themselves when the heat becomes too intense. If a sensor detects that the shield has slipped even a fraction of a degree, the computer corrects the alignment before the instruments can be fried. If we were to look closer at these machines, we would see them not just as tools, but as extensions of our own senses and our collective will to explore. They see the light we cannot see and feel the heat we could never endure, sending back a tapestry of data that expands our understanding of the cosmos. They are the silent champions of our species, standing firm in the heart of the storm to light the way for our future. The future of our exploration often depends on these quiet champions, who endure the long, freezing silence of the abyss to light the way toward the farthest reaches of the unknown. After a journey spanning billions of miles and nearly a decade, the New Horizons spacecraft streaked past the dwarf planet Pluto at an incredible velocity, capturing the first detailed portraits of an unexpectedly complex world. In the faint twilight glow of a distant sun casting long shadows on nitrogen glaciers, a massive heart-shaped feature known as Sputnik Planitia appeared across the frozen surface. This structure, a vast basin filled with churning nitrogen ice, behaves like a slow-motion ocean that constantly refreshes its own surface through a process of geological convection. Surprisingly, the universe has created a world that feels rhythmically alive despite the staggering cold, where massive glaciers flow around towering mountains and fill deep, ancient craters with fresh white frost. The heartbeat of this distant world is written in these pale, icy plains that shimmer with a ghostly light, revealing a landscape that is both alien and hauntingly beautiful. If we were to look closer at the edges of this frozen heart, we would see intricate patterns of dark pits and ridges carved by the sublimation of ice directly into the thin air. It is a place of absolute stillness and monumental motion, where the passage of time is measured in the slow drift of nitrogen flows across a rusted ancient crust. As you settle into your seat, imagine the immense scale of this icy expanse, a gleaming jewel tucked away at the very edge of our sun's domain. Surprisingly, the universe at the extreme edge of our solar system is not a monochrome expanse of grey stone and white ice, but is painted in deep, rust-like reds that defy the gloom. This haunting colour is the result of complex organic molecules known as tholins, which are forged when ultraviolet light reacts with methane and nitrogen ices over billions of years. These reddish stains coat the ancient surfaces of Kuiper Belt objects, creating a startling visual contrast against the brilliant crystalline white of the frozen gases. If we were to look closer at the chemical soot drifting down from the hazy skies, we would see the primordial building blocks of a complex and ancient chemistry. These molecules represent the slow, cold evolution of matter in the lightless reaches of the void, where time itself seems to stand still. The faint twilight glow of a distant sun casting long shadows on nitrogen glaciers illuminates these ruby-tinted wastes, revealing a world of surprising warmth in its visual palette despite the biting chill. This reddish dust acts as a planetary signature, marking the surfaces of worlds that have been exposed to the cosmic environment since the dawn of our star. It is a material that links the distant ice dwarfs to the earliest moments of our solar system's birth. As the spacecraft glides over these blood-red plains, it records a history written in the very colour of the ground, a narrative of chemical change spanning eons of silent time. Deep within the Kuiper Belt, the spacecraft continued its lonely trek to encounter a relic from the very beginning of the solar system's creation. Arakoth appeared out of the darkness, a bizarre and ancient object shaped like two distinct lobes joined at a narrow neck, resembling a flattened reddish snowman. This primordial structure was formed by the gentle, slow-motion collision of two smaller bodies that merged billions of years ago in a quiet, gravitational embrace. The faint twilight glow of a distant sun casting long shadows on nitrogen glaciers provided just enough light to map the cratered surface of this distant, primitive wanderer. It is a pristine specimen of the planetary building blocks that once swirled in the massive disk around our young and growing star. Its preservation in the deep freeze of the outer system allows us to witness the quiet, constructive forces of gravity that originally shaped our entire cosmic neighbourhood. If we were to look closer at the smooth surface of this twin-lobed world, we would see no signs of violent impact or catastrophic disruption. Instead, it represents the peaceful assembly of matter, a slow and orderly process that built the foundations of the planets we know today. It is a silent witness to the earliest days of our home, floating in the dark like a piece of cosmic history frozen forever in time. The towering mountains of Pluto rise several miles into the thin, freezing atmosphere, casting immense and jagged silhouettes across the surrounding nitrogen plains. Unlike the peaks on Earth, these colossal structures are not made of silicate rock or volcanic basalt, but of water ice that has become as hard as steel in the extreme cold. At these temperatures, the water ice behaves like a rigid mineral, capable of supporting the weight of massive mountain ranges that would otherwise collapse under their own mass. If we were to look closer at the jagged ridges of the Tenzing Montes, we would see that they are often capped with bright methane snow shimmering like diamonds in the perpetual gloom. The faint twilight glow of a distant sun casting long shadows on nitrogen glaciers creates a landscape of stark beauty and impossible frozen scales. These heights stand as a testament to the strange properties of familiar materials when subjected to the brutal environment of the outer dark. Surprisingly, the universe allows for the existence of mountains that are essentially giant blocks of frozen water ice floating on a denser bed of churning nitrogen. This interaction creates a world where the very mountains can drift and shift over immense geological timescales. As your body rests in a state of deep calm, imagine the thin, cold wind whistling between these icy peaks, miles above the frozen heart of the planet. Pluto's largest moon, Charon, presents a face that is equally dramatic and scarred, dominated by a massive canyon system that stretches across its entire equator. If we were to look closer at this tectonic wound, we would find a chasm 4 times as long and twice as deep as the Grand Canyon found on our homeworld. This structure likely formed when a subsurface ocean froze and expanded, splitting the moon's crust from the inside out in a violent and ancient geological event that reshaped the entire moon. Notice the rhythmic rise and fall of your chest as you contemplate the scale of this fractured moon drifting in the eternal silence of the void. The faint twilight glow of a distant sun casting long shadows on nitrogen glaciers on Pluto reflects onto Charon, bathing the canyon walls in a dim secondary light. It is a world of silent, frozen trauma, where the history of its internal struggles is written in the deep cracks and jagged cliffs of its shattered surface. The northern pole of this moon is stained with a dark reddish cap of organic material, a gift of gas that escaped from Pluto's atmosphere and settled in the freezing cold. This interaction links the two worlds in a constant, invisible exchange of matter across the empty space between them, as if they were sharing their very breath. They are a binary pair, locked in a gravitational dance that has shaped their surfaces and their destinies for billions of years in the outer reaches. Slowly drifting outward toward the interstellar threshold, the probe continues to perform a unique and vital scientific task in the purest darkness currently available to humanity. It measures the faint cosmic background light, the collective glow of all the galaxies and stars that have ever existed throughout the history of the universe. By operating so far from the glare of our own sun and the dust of the inner solar system, the spacecraft can see the true darkness of the deep cosmos. This measurement helps astronomers determine if there are hidden sources of light in the universe that we have not yet accounted for in our current models. The faint twilight glow of a distant sun casting long shadows on nitrogen glaciers is the only local illumination the spacecraft ever experiences as it sails into the night. In this absolute isolation, it serves as our most sensitive instrument for gauging the ultimate brightness of the entire created order. If we were to look closer at the data, we would find that the universe is slightly brighter than we expected, hinting at the existence of unknown stars or distant galaxies. This discovery challenges our understanding of the cosmic structure and the evolution of light throughout time. The spacecraft remains our lonely outpost in the dark, staring into the abyss to find the faint signal of the first light ever born. As the spacecraft sped away from the dwarf planet, it turned its cameras back one final time to capture a haunting and iconic view of the world it had just met. The thin blue atmosphere of Pluto was revealed in a stunning backlit photograph, appearing as a glowing ring of sapphire light around the dark silhouette of the planet. This layer of haze is composed of hundreds of individual rings, created as nitrogen and methane interact with the harsh solar wind. Surprisingly, the universe has gifted this distant, cold world with a sky that looks remarkably like our own during a clear, crisp twilight. The faint twilight glow of a distant sun casting long shadows on nitrogen glaciers filters through these hazy layers, scattering blue light into the surrounding darkness of the Kuiper Belt. This single image proved that Pluto is not a dead, airless rock, but a complex world with a dynamic and startlingly beautiful atmosphere. If we were to look closer at the structure of these hazy layers, we would find that they extend for hundreds of miles above the surface, far higher than anyone predicted. This atmosphere expands and contracts as the planet moves through its long, elliptical orbit around the Sun. It is a breathing world, a fragile bubble of gas clinging to the edge of the void, illuminated by the distant spark of our star. These distant, icy bodies are much more than just remote curiosities. They are the pristine remnants from the formation of the outer planets. Preserved in a deep freeze that has lasted for over 4 billion years, they hold the original recipe of the solar system within their frozen, unevolved hearts. By studying these objects, we can look back at the chaotic era when the giant planets were migrating and the Kuiper Belt was being formed from the leftovers of planetary creation. Notice the absolute stillness of your body, fully supported by your surroundings, as you ponder the vastness of time held within these icy spheres. The faint twilight glow of a distant sun casting long shadows on nitrogen glaciers falls on materials that have remained unchanged since the very dawn of our sun. They are the chemical library of our origins, waiting in the dark to tell the story of how our planetary home was originally assembled from stardust and ice. Surprisingly, the universe has kept these time capsules safe at the extreme edge of the system, away from the heat and chaos of the inner worlds. They contain the water and organic molecules that may have been delivered to the young Earth during the late heavy bombardment, potentially seeding the first life. Every crater and ridge on these surfaces is a record of a collision that happened when the solar system was still in its earliest infancy, a memory frozen in stone. The journey to the edge of the solar system took nearly an entire decade, requiring the spacecraft to cross billions of miles of empty, radiation-filled space. To conserve its limited electrical power and ensure its delicate instruments survived the long trek, the probe spent most of its voyage in a state of deep electronic hibernation. It drifted silently through the dark, waking up only for brief scheduled check-ins with a team of engineers waiting back on Earth. This strategy required immense patience, and the ultimate trust in the engineering of a machine that had to function perfectly after years of cold sleep. The faint, twilight glow of a distant sun casting long shadows on nitrogen glaciers was a goal that took a significant portion of a human lifetime to finally reach. When the craft arrived, it performed its task with flawless precision, proving that we can reach across the vastness of the void to touch the most distant members of our family. If we were to look closer at the speed of this journey, the spacecraft was moving so fast that it crossed the entire orbit of the Moon in just 9 hours. Yet, even at that staggering velocity, it took years to reach the dwarf planet and its many moons. The sheer scale of our solar system is a humbling reality that these long-distance probes help us to finally comprehend through their patient, silent travel. As our probes reach the Kuiper Belt, they prove that even the coldest and most distant worlds possess a surprisingly active and complex geology. We once expected to find cratered static balls of ice, but instead we found worlds with moving glaciers, tectonic fractures, and potentially even active cryovolcanoes. The faint twilight glow of a distant sun casting long shadows on nitrogen glaciers reveals a universe that is far more dynamic than we ever dared to imagine during the centuries of distant observation. Deep within the heart of these dwarf planets, internal heat sources continue to drive geological processes that reshape the surface even today. This realization has expanded our definition of what it means for a world to be geologically alive, showing that activity can occur even at the very edge of our star's influence. As you rest in a state of deep, peaceful wonder, consider that the dark is not empty, but filled with vibrant, evolving worlds that challenge our most fundamental understandings of the cosmos. This structure, the Kuiper Belt, is a vast frontier of thousands of small worlds that we are only beginning to explore and understand. Each one holds a different piece of the puzzle, a unique variation on the theme of ice and rock in the deep, lightless dark. The champions of our species continue to fly onward into the abyss, their mission never truly ending as they search for the next horizon in the eternal night. While some champions of our species continue to search for the next horizon in the eternal night, others have turned their gaze back toward the origin of our journey. The Discover satellite sits 1 million miles away at the L1 Lagrange point, where the gravity of the Earth and the Sun reach a perfect silent equilibrium. From this unique vantage point, it constantly watches the sunlit face of Earth to monitor space weather and provides an early warning system against solar storms. The rhythmic, mechanical clicking of camera shutters capturing the blue marble below is constant for this probe, which takes a full-colour image of the Earth every few hours. These photographs show our world as a single glowing sphere suspended in the velvet blackness of the void. Surprisingly, the universe looks quite different from this distance, as the satellite captures the Moon crossing the face of the Earth in a rare and haunting celestial transit. By examining the data streaming from DSCO-VR, we find a complex record of ozone levels, cloud heights, and vegetation health across the entire globe. This structure of observation provides the necessary context for understanding the Earth's climate on a truly planetary scale. It serves as a bridge between the study of our star and the protection of our home, reminding us that we live within the outer atmosphere of the Sun. High in orbit, the Landsat program has spent half a century continuously photographing the changing forests, cities, and coastlines of our home. This monumental archive serves as a collective memory for humanity, allowing us to see how the surface of the Earth has been reshaped by both natural forces and our own expansion. From the green canopies of the Amazon to the sprawling concrete of urban centres, no detail escapes the unblinking watch of these orbiting cartographers. The rhythmic, mechanical clicking of camera shutters capturing the blue marble below has documented the retreat of ancient glaciers and the rise of new islands over decades. Each mission builds upon the work of the previous generation, creating a seamless time-lapse of a planet in transition. Surprisingly, the universe reveals our history through the shifting colours of the landscape, where the scars of fire and the growth of crops tell a story of survival and change. By examining the thousands of images stored in this digital library, we can see the staggering scale of our impact on the biosphere. These satellites do not just map geography, they record the pulse of civilization as it spreads across the continents. They remain our most reliable witnesses to the physical reality of a world that is moving faster than ever before. This delicate network of weather satellites tracks hurricanes and storms, saving countless lives by providing early warnings long before the clouds reach land. Positioned in geostationary orbits thousands of miles above the equator, these sentinels keep an eternal watch over specific hemispheres, never losing sight of the brewing tempest below. They monitor the subtle shifts in temperature and moisture that signal the birth of a tropical depression in the middle of the vast oceans. The rhythmic, mechanical clicking of camera shutters capturing the blue marble below allows meteorologists to observe the spiral patterns of wind and rain as they coalesce into massive cyclonic systems. By tracking the path of a hurricane in real time, these satellites provide the vital data necessary to evacuate coastal cities and prepare for the coming surge. Surprisingly, the universe shows us the raw power of the atmosphere through the lens of these machines, turning chaotic weather into a predictable science. Take a moment to feel your body resting in total comfort, safe in the knowledge that these high-altitude guardians are watching over the horizon. The infrastructure of our modern world relies on this invisible web of information to navigate the challenges of a volatile climate. Without their constant vigilance, we would be blind to the giant storms that move silently across the face of the deep. Surprisingly, the GRACE mission measured the changing mass of Earth's ice sheets by tracking minute variations in gravity rather than using traditional visual cameras. This pair of twin satellites, nicknamed Tom and Jerry flies, in a precise tandem orbit, constantly measuring the distance between one another with incredible accuracy. As the lead satellite passes over a region with greater mass, such as a mountain range or a dense ice sheet, this slight increase in gravitational pull tugs it forward. The rhythmic, mechanical clicking of camera shutters capturing the blue marble below is replaced here by the silent, invisible feeling of the planet's weight. By monitoring how the distance between the two crafts changes, scientists can map the movement of water across the globe and the melting of the polar caps. This structure of measurement has revealed that billions of tons of ice are vanishing from Greenland and Antarctica every year, contributing to the rising of the seas. Deep within the gravity maps produced by this mission, we see the Earth as a lumpy, uneven sphere of shifting weight. It reveals the hidden depletion of deep underground aquifers and the seasonal flow of the great river basins. This mission has transformed our understanding of the planet's hydrology, showing us that even the most solid-looking landscapes are in a state of constant gravitational flux. The Aqua and Terra satellites monitor the delicate balance of the planet's water cycle, from ocean currents to the thickness of cloud cover that regulates our temperature. These sister craft fly in sun-synchronous orbits, ensuring they pass over every location on Earth at the same local time each day to maintain consistent data. They act as the primary sensors for Earth's health, measuring everything from the surface temperature of the sea to the amount of carbon dioxide absorbed by forests. Notice the rhythmic, mechanical clicking of camera shutters capturing the blue marble below, as these satellites scan the globe in wide, sweeping swaths. They capture the bloom of phytoplankton in the oceans and the smoke from distant wildfires, revealing the intricate connections between the water, the air, and the land. Surprisingly, the universe reveals a world that is constantly breathing as these machines track the seasonal rise and fall of global vegetation. Let your breathing become soft and steady, mirroring the calm, rhythmic cycles of the atmosphere being monitored by the machines overhead. This mission provides the foundational data for our global climate models, helping us to predict how our world will react to a changing environment. They are the unblinking eyes that see the Earth not as a collection of countries, but as a single, living, and breathing system. Gliding silently above the atmosphere, the Hubble Space Telescope has revolutionized our understanding of the cosmos, while remaining in low Earth orbit as a sentinel of human perspective. While most of its work involves peering into the farthest reaches of space, Its position just above the clouds makes it a unique part of our planetary defense and observation network. It provides a level of clarity that ground-based telescopes can never achieve, free from the blurring effects of the thick protective air. The rhythmic mechanical clicking of camera shutters capturing the blue marble below accompanies its countless observations of the infinite. It has mapped the atmospheres of distant planets and the birth of stars in nebulae that lie thousands of light years away. Surprisingly, the universe looks both vast and intimate through its lens, reminding us that our home is a tiny, fragile outpost in a much larger and older galactic neighbourhood. Throughout its storied history, this telescope has changed our very sense of place in the cosmos. It has captured the collision of comets with Jupiter and the faint glow of the most distant galaxies ever seen. Even as newer telescopes launch, this aging sentinel continues to provide a vital window into the mysteries that surround our small blue world. The ICESat lasers measure the precise thickness of polar ice, revealing the rapid changes occurring in the Arctic and Antarctic with high-resolution accuracy. By firing thousands of pulses of light every second and timing their return from the surface, these satellites can measure the elevation of the ice with the precision of a few centimeters. This data allows scientists to track the thinning of glaciers and the movement of sea ice as the planet warms. The rhythmic mechanical clicking of camera shutters capturing the blue marble below is supplemented here by the invisible rhythmic pulsing of laser light through the cold polar air. Surprisingly, the universe at the poles is a place of constant structural change, as massive shelves of ice fracture and slide into the warming southern oceans. These measurements provide a clear and undeniable record of the physical transformation of our planet's frozen frontiers. Notice the weight of your body as gravity holds you close to the Earth, the same force that these satellites use to maintain their eternal vigil. The information gathered by these lasers is critical for predicting future sea level rise and the survival of polar ecosystems. It is a mission of extreme technological precision, turning beams of light into a defense for our world's most vulnerable regions. Through the lenses of these inward-looking probes, humanity can see the fragile, interconnected systems of our biosphere as a single pulsing organism. We can watch as a dust storm in the Sahara travels thousands of miles across the ocean to provide vital nutrients to the Amazon rainforest. These satellites show us that a change in one part of the world has an immediate and measurable impact on the health of the entire planet. The rhythmic, mechanical clicking of camera shutters, capturing the blue marble below, reveals a world without borders, where the air and water flow freely across the continents. Surprisingly, the universe has created a closed system that is perfectly balanced to support life, provided we understand and respect its limits. This perspective shift, often called the overview effect, has been made possible by the constant stream of data from our orbital sentinels. By tracing the chemical signatures of the oceans and forests, we find a world that is struggling to maintain its equilibrium. These machines capture the invisible signals of stressed ecosystems and the bleaching of coral reefs in the warm tropical seas. They serve as a global early warning system, showing us the beauty and the peril of our interconnected life support system. The swarm satellites map the Earth's magnetic field, tracking how it weakens and shifts over time to understand the mysterious movements of our planet's core. This trio of satellites flies in a coordinated formation, measuring the magnetic signals from the Earth's interior, the crust, and the surrounding ionosphere. They provide a three-dimensional map of the invisible shield that protects us from the lethal radiation of the sun and the high-energy particles of deep space. The rhythmic, mechanical clicking of camera shutters capturing the blue marble below is absent for these magnetic hunters, who instead record the invisible lines of force that envelop the globe. Surprisingly, the universe reveals that our magnetic poles are not fixed, but are constantly wandering, and even losing strength as the molten iron deep below us shifts its flow. This data is vital for maintaining the navigation systems and satellite infrastructure that our modern civilization depends on every day. Picture the swirling currents of liquid metal thousands of miles beneath your feet, generating the power that these satellites detect from above. This hidden engine is the heart of our world, and its fluctuations are a reminder that the Earth is a dynamic and changing sphere. The Swarm mission provides the only way to peer into the deep metallic darkness of the core from the safety of the heavens. These silent sentinels provide the data necessary to understand the vast global impact of human activity on the planet over the last century. From the bright, sprawling lights of our cities visible in the night to the industrial scars carved into the landscape, our signature is written across the face of the Earth. These satellites record the loss of biodiversity and the expansion of agriculture, documenting the transformation of the wilderness into a human-dominated landscape. The rhythmic, mechanical clicking of camera shutters capturing the blue marble below serves as a planetary mirror, forcing us to confront the consequences of our choices. Surprisingly, the universe shows us that even our most massive works are fragile when viewed from the perspective of the orbital void. This collective intelligence gathered by our probes is the ultimate tool for steering our civilization toward a more sustainable and balanced future. As you drift into a state of deep, peaceful wonder, consider that these machines are the unblinking guardians of our only home. They watch over us while we sleep, measuring the breath of the forests and the pulse of the oceans to ensure we understand the world we inhabit. Their mission is a testament to our curiosity and our commitment to protecting the small blue marble that sustains all we have ever known. While we cherish that small blue marble, our restless curiosity inevitably pulls us toward the very beginning of the light that defines all we have ever known. 1,000,000 miles from our home, the James Webb Space Telescope rests in the absolute stillness of a mirror cooling to near absolute zero in deep space. To catch the incredibly faint infrared signals from the first dawn of the universe, the machine must exist in a state of thermal silence so profound it defies terrestrial experience. This structure, protected by a sun shield the size of a tennis court, slowly unfolds its 18 golden honeycomb mirrors to create a single, massive eye. Because the expansion of the universe has stretched the light from the most ancient galaxies into long infrared wavelengths, only this specialized golden surface can capture their ghostly presence. It peers through the vast corridors of time, seeking the elusive spark of the very first stars to ever ignite in the cosmic dark. Surprisingly, the universe reveals its deepest secrets only when we have moved far enough away from the heat of our own star to listen. The telescope captures images of infant galaxies as they appeared over 13 billion years ago, long before our own sun was even a cloud of dust. As you breathe in the cool air of the present, imagine the absolute stillness of that golden mirror, waiting patiently for a single photon that has travelled across the entire history of time. Deep within the silence of a specialized orbit far beyond the interference of our atmosphere, the Planck satellite performed a task of monumental sensitivity. It was designed to detect the cosmic microwave background, the incredibly faint residual heat left over from the Big Bang itself. To achieve this, its instruments were cooled to temperatures colder than any natural place in the known universe, sitting just a fraction of a degree above absolute zero. This structure mapped the entire sky with unprecedented precision, capturing the mottled pattern of hot and cold spots in the early universe's first light. These fluctuations represent the primordial seeds of all the galaxies, stars, and planets that would eventually form in the eons to follow. The absolute stillness of a mirror cooling to near absolute zero allowed the satellite to discern variations in temperature that are smaller than a millionth of a degree. If we were to look closer at the resulting map, we would see a portrait of the cosmos as it existed only 300,000 years after its birth. It is the ultimate baby picture of our universe, providing the fundamental blueprint for everything we see in the night sky. Feel the profound calm of this ancient lingering glow as you realize that the heat of creation still echoes through every inch of the space around you. This massive observatory, Kepler, demonstrated a level of focus that is nearly impossible for any human mind to comprehend. For years, it stared unblinkingly at a single crowded patch of the Milky Way, monitoring the brightness of over 100,000 stars simultaneously. It was not looking for brilliant flares or cataclysmic explosions, but for the tiniest, most subtle dips in starlight imaginable. Surprisingly, the universe is teeming with hidden worlds that only reveal themselves when they pass directly in front of their parent stars. These fleeting shadows, known as transits, were captured by Kepler's digital sensors with enough precision to calculate the size and orbit of thousands of new exoplanets. It revealed that our galaxy contains more planets than it does stars, a discovery that fundamentally changed our understanding of our place in the cosmic hierarchy. Notice how your own heart maintains a steady rhythmic pulse, much like the celestial clockwork that Kepler watched for so long. The absolute stillness of a mirror cooling to near absolute zero is a requirement for such detection, as any internal heat would swamp the delicate signal of a distant planet. Through this unmoving stare, we have found worlds made of diamond, planets with two suns, and rocky spheres that might just harbour liquid water. Surprisingly, the universe is often veiled behind thick, impenetrable walls of cosmic dust that block our view of the most active star-forming regions. The Spitzer Space Telescope was specifically designed to pierce these opaque curtains by observing in the infrared spectrum where dust becomes transparent. It allowed us to see directly into the turbulent hearts of nebulae, revealing the violent and beautiful birth of new planetary systems. If we were to look closer at the famous pillars of creation through Spitzer's eyes, the dark towers of gas would vanish, exposing the brilliant infant stars huddled within. This ability to see heat rather than visible light turned the cold, dark clouds of the galaxy into vibrant laboratories of creation. The absolute stillness of a mirror cooling to near absolute zero ensured that the telescope was not blinded by its own thermal radiation while mapping the infrared universe. As you allow your muscles to relax into a state of deep rest, imagine the warmth of a newborn sun glowing through a cloud of dust billions of miles away. Spitzer mapped the distribution of water in the interstellar medium and even detected the weather patterns on massive distant gas giants. It provided a new, thermal perspective on the cosmos, showing us that the dark voids are often the most crowded places in the sky. Picture a realm where the universe is no longer a place of gentle starlight, but a landscape of fierce energy and high-speed collisions. The Chandra X-ray Observatory detects the invisible high-energy light emitted by black holes, supernova remnants, and the hot gas that fills the clusters of galaxies. Because X-rays are absorbed by our atmosphere, this specialized telescope must sit high above the clouds to witness the most violent events in the cosmos. This structure uses mirrors shaped like long nested cylinders to gently skip X-ray photons toward a focal point, as they are too energetic to be reflected by a flat surface. It has captured the intense glow of matter as it is shredded and heated to millions of degrees before disappearing into a black hole's event horizon. The absolute stillness of a mirror cooling to near absolute zero allows its detectors to separate these high-energy signals from the background noise of the spacecraft's electronics. Deep within the glowing debris of an exploded star, Chandra reveals the chemical elements that will one day form the next generation of planets and people. It sees the iron in our blood and the calcium in our bones being forged in the heart of a cosmic catastrophe. Let the strength of this realization ground you as you contemplate the immense power required to light up the sky in the X-ray spectrum. Notice how the map of our own galaxy is being rewritten by a sentinel that measures the stars with the precision of a master watchmaker. Deep within the second Lagrange point, the Gaia mission is currently undertaking the most ambitious census of our cosmic neighbourhood ever attempted. It is creating a precise three-dimensional map of our Milky Way galaxy by tracking the exact position, distance, and motion of over 1 billion individual stars. This monumental task requires the spacecraft to measure the tiny, apparent shift of a star's position as Gaia orbits the Sun, a technique known as parallax. Gaia is so precise that it could measure the width of a human hair from a distance of over 500 miles away. The absolute stillness of a mirror cooling to near absolute zero is essential for maintaining the extreme stability needed for such microscopic angular measurements. If we were to look closer at the results, we would see Gaia reconstructing the history of our galaxy, revealing how the Milky Way has swallowed smaller galaxies over billions of years. It is a mission of pure geometry, turning the chaotic sprawl of the night sky into a structured three-dimensional masterpiece. As you rest in the quiet of the present, imagine the billion stars of our home galaxy drifting in their vast slow-motion orbits. This cosmic observatory, the Wilkinson Microwave Anisotropy Probe, provided the definitive answer to one of humanity's most ancient questions about the nature of time. By measuring the cosmic microwave background with incredible detail, it allowed scientists to calculate the precise age of the universe. It pinned down the beginning of all things to nearly 14 billion years ago, giving us a concrete timeline for the evolution of the cosmos. Surprisingly, the universe has left its age written in the patterns of light that have been travelling toward us since shortly after the Big Bang. WMAP analysed these patterns to determine the composition of the universe, proving that ordinary atoms make up only a tiny fraction of everything that exists. The absolute stillness of a mirror cooling to near absolute zero was the silent foundation upon which this entire skyscraper of cosmological knowledge was built. If we were to look closer at the data, we would find that the universe is currently expanding at an accelerating rate, driven by a mysterious force called dark energy. This discovery has forced us to reconsider the ultimate fate of all things, suggesting a future of infinite lonely expansion. As you rest in the quiet of the present moment, consider the immense span of time that has passed to bring you to this exact point in history. Imagine pointing the world's most powerful telescope at a tiny, seemingly empty patch of darkness for 10 consecutive days, hoping to see something where there was nothing. When the Hubble Space Telescope performed this experiment, it revealed thousands of galaxies in the iconic deep field image, each one containing billions of stars. This single photograph showed that the universe is filled to the brim with galaxies, even in the parts of the sky that appear completely void to our eyes. Deep within this image, we see galaxies as they were when the universe was less than 1 billion years old, showing us the chaotic process of how cosmic structures are built. The absolute stillness of a mirror cooling to near absolute zero allows the telescope to keep its gaze fixed on these faint, distant targets without any internal vibrations blurring the view. It was a moment of profound revelation, proving that the more we look into the dark, the more light we find waiting for us. This structure of galaxies stretching back into the infinite past is a reminder of the sheer scale of the universe we inhabit. Every tiny speck in that image is a whole world unto itself, potentially filled with planets, moons, and the same fundamental laws of physics we study on Earth. Let the magnitude of this discovery expand your perspective as you realize how much of the cosmos remains to be explored. Deep within the neighborhood of our own sun, the transiting exoplanet survey satellite is currently hunting for the worlds that might one day be within our reach. Unlike previous missions that looked at a single distant patch, TESS scans the entire sky in sectors, focusing on the brightest and closest stars to Earth. It is specifically designed to find Earth-sized planets orbiting small, cool stars that are our nearest cosmic neighbours. Surprisingly, the hunt for our neighbours has already revealed a staggering diversity of worlds, many of which are radically different from the planets in our own system. TESS identifies candidates that are then studied by larger telescopes like Webb to determine if they possess atmospheres or the potential for life. The absolute stillness of a mirror cooling to near absolute zero provides the necessary stability for TESS to detect the minute flickers of nearby stars. Take a slow, deep breath and feel the air fill your lungs, contemplating the possibility of a similar world orbiting a star just a few dozen light years away. TESS is creating a directory of destination worlds, a map for the future of interstellar exploration that begins right in our own backyard. It is a mission of proximity, turning the stars we can see with our naked eyes into the centres of new and unexplored solar systems. These space-based telescopes represent the ultimate escape from the limitations of our homeworld, rising above the thick, turbulent atmosphere that blurs our view of the heavens. By sitting in the vacuum of space, they avoid the twinkling effect caused by moving air, allowing them to achieve a level of sharpness that no ground-based instrument can ever match. They serve as our sharpest eyes into the deep past, capturing light that has been travelling toward us since before the Earth even existed. This structure of orbital observation allows us to see the universe across the entire electromagnetic spectrum, from the highest energy X-rays to the longest infrared waves. Without the filtering effect of our atmosphere, we can witness the true colours and intensities of the cosmos as they really are. The absolute stillness of a mirror cooling to near absolute zero is the silent, cold reality that makes this unprecedented vision possible. If we were to look closer at the progress of astronomy, we would see that more has been discovered in the last few decades of space telescopes than in all the centuries that came before. They are the true time machines of our species, allowing us to witness the history of the universe in real time. As you drift into a state of deep, peaceful wonder, realize that we are finally looking out into the dark and seeing it clearly for the very first time. The farther our space probes look into the cosmos, venturing past the familiar rings and rusted plains, the more we realize how uniquely rare our blue planet might be. We have catalogued thousands of worlds, from scorched iron spheres to frozen ice dwarfs, yet none replicate the delicate, vibrant equilibrium of Earth. The profound, echoing silence of an expanding emptiness stretching toward infinity highlights the isolation of our temperate oasis. Deep within the lightless corridors of the galaxy, the search for a second home reveals a universe filled with extremes that make our existence seem like a precarious miracle. If we were to look closer at the exoplanets detected by our orbiting observatories, we would find worlds where it rains glass sideways, or where the very air is composed of vaporized rock. This structure of the planetary archive serves as a dark mirror, reflecting the impossible grace of a world where the water remains liquid and the sky remains blue. Take a slow, deep breath and feel the weight of your body pressing into your seat, a tangible connection to the gravity of the only world that has ever breathed with us. Every desert we map and every frozen moon we fly past emphasizes the staggering odds of our own existence. We are a solitary spark in a dark room of impossible dimensions, a realization that brings a quiet, humbling grace to our planetary identity. Every byte of data sent back across the void travels at the speed of light, yet still takes hours or years to reach us. This creates a strange, disconnected dialogue where we are perpetually talking to the ghost of a spacecraft's past position. The profound, echoing silence of an expanding emptiness stretching toward infinity swallows the radio waves, stretching them thin as they race toward the massive dishes of the deep space network. Surprisingly, the universe imposes a strict speed limit on the flow of information, ensuring that we can never truly experience the cosmos in real time. By the time the telemetry from a distant probe reaching the edge of the system is processed on Earth, the machine itself has already travelled thousands of miles further into the dark. We are forever chasing the current state of our explorers, receiving their reports as echoes from a moment that has already passed into history. Notice how the rhythm of this communication requires a monumental level of patience and trust in the mathematics that guide our machines. Deep within the mission control centres, engineers wait for hours in total silence for a single signal that confirms a command was received across billions of miles. It is a slow, rhythmic conversation with the infinite, a process that turns the act of data collection into a form of cosmic meditation. This immense distance means we're always looking into the past, seeing planets and stars as they were when the light first began its journey, not as they exist in this very moment. When we observe a distant solar system, we are witnessing a version of reality that may have already been extinguished, or transformed by the passage of billions of years. The profound, echoing silence of an expanding emptiness stretching toward infinity ensures that our visual records are always a collection of cosmic memories. If we were to look closer at the light from the farthest galaxies, we are seeing the universe in its infancy, a time long before our own sun was even a whisper of gas. This structure of temporal delay turns the night sky into a grand museum of prehistoric snapshots, where the history of all creation is laid out before us in a single silent view. Surprisingly, the universe allows us to be time travelers simply by looking up, offering us a window into the origins of everything we see. Surprisingly, the universe is mostly composed of dark matter and dark energy, substances our instruments can only detect through their gravity. Our luminous stars and vast nebulae are merely a dusting of light on a dark, invisible mountain that we cannot directly perceive with traditional optics. This structure of the invisible majority guides the movement of galaxies and the very expansion of space itself, yet it remains fundamentally untouchable. Deep within the equations of our astrophysicists, the weight of the missing matter reveals a universe that is far heavier and more energetic than the parts we can see. The profound, echoing silence of an expanding emptiness stretching toward infinity is filled with this unseen presence, a dark scaffolding upon which the visible stars are hung like holiday lights. We are sailors on a vast dark sea, navigating by the pull of currents that we can only sense through the way our ships drift. If we were to look closer at the fate of the cosmos, we would see dark energy acting as a cosmic repeller, pushing the galaxies apart at an ever-increasing rate. This invisible force is the ultimate ruler of the void, ensuring that the future of the universe is one of increasing isolation and darkness. As you relax and let go of the day's tension, contemplate the mystery of this unseen world that cradles everything we know. If we were to look closer at the subatomic scale, we would find that the fabric of space itself is a frothing, active foam of energy and possibility. This structure of the vacuum provides the very stage upon which the stars and galaxies perform their ancient dance of light and gravity. Surprisingly, the universe is built upon a foundation of constant movement, where even the most desolate regions are filled with the silent music of quantum mechanics. Notice how the stillness of your own room is built upon the same energetic reality, a quiet stability that masks the incredible activity of the physical world. We are living on the surface of a deep and active ocean of energy, a realization that turns the idea of the void into a masterpiece of hidden complexity. As you relax, let the idea of this universal hum provide a sense of connection to the very fabric of space itself. Slowly, our most distant probes are escaping the sun's gravitational pull for the final time, embarking on a journey that will outlast the life of our star. Having crossed the threshold of the heliopause, these metallic wanderers are now destined to wander the Milky Way forever, untethered from the hearth of the solar system. The profound, echoing silence of an expanding emptiness stretching toward infinity will be their only companion as they begin an orbit that takes hundreds of millions of years. These silent ambassadors carry our messages and our technology into a realm where the concept of a year is measured by the rotation of the entire galaxy. They are the first artifacts of our species to achieve a kind of mechanical immortality, surviving long after the planet that launched them has changed beyond recognition. If we were to look closer at their trajectories, they will eventually pass by distant stars and enter unknown nebulae, representing the first human presence in the interstellar dark. Picture the absolute stillness of these craft as they glide through the vacuum, their instruments quiet and their hearts long since gone cold. They are the seeds of a future memory, drifting through the galactic tides like lightless husks of dragonflies captured in amber. Their journey is a testament to our desire to leave a mark on the infinite, a silent signature etched into the very fabric of the stars. The silence of the void forces us to confront the great filter, the philosophical question of why we have not yet detected other civilizations in a universe so vast and old. Despite decades of listening with our most sensitive antennas and scanning the atmospheres of distant exoplanets, we have yet to detect a single whisper from another intelligence. The profound, echoing silence of an expanding emptiness stretching toward infinity becomes a mirror, reflecting our own fragility and the potential rarity of life that can reach the stars. Surprisingly, the universe has not yet revealed the presence of others, leading us to wonder if we're the first to look up, or perhaps the last survivors of a lonely race. This structure of the unknown creates a sense of urgency in our own survival, as we realize that the flame of consciousness might be a flickering light in a very dark room. If we were to look closer at the laws of probability, the silence is a staggering anomaly that demands we treasure the life we find here on our homeworld. Take a moment to feel the absolute peace of your surroundings, the quiet safety that is so rare in the wider context of the cosmos. Our search for others is ultimately a search for our own future, a quest to see if it is possible to endure across the immense scales of time and space. The void remains unanswering, a silent sphinx that challenges us to be the best stewards of the only life we know for certain. As our machines map the cosmic web of galaxies, they reveal a structure that closely resembles the neural networks of a human brain. Long, glowing filaments of galaxies are separated by immense lightless voids, forming a grand architecture of connectivity that spans the entire observable universe. This structure suggests a universal principle of organization that repeats from the smallest biological cell to the largest grouping of matter in existence. If we were to look closer at the scaffolding of dark matter that supports these galactic threads, we would see a universe that is far more organized than it appears to the naked eye. The profound, echoing silence of an expanding emptiness stretching toward infinity is not a sign of chaos, but the space between the nodes of a cosmic intelligence. We are living inside a network of light and gravity that functions with a complexity that humbles our most advanced computer models. Surprisingly, the universe reveals a startling symmetry between the macrocosm and the microcosm, where the largest structures imaginable mirror the very engines of our thought. As you rest in the quiet of the present, imagine the vast, slow-motion electrical signals of gravity pulsing through these cosmic filaments. We are part of a connected whole, a single, pulsing organism of light and matter that stretches across the deep. The extreme conditions measured by these probes show that the universe is simultaneously profoundly hostile and breathtakingly beautiful. We find radiation belts that would fry a human in seconds, and pressures that crush lead into liquid, yet these same forces produce the shimmering auroras and the elegant rings of ice that we find so captivating. The profound, echoing silence of an expanding emptiness stretching toward infinity is the canvas for this violent and gorgeous masterpiece. Deep within the heart of a supernova, the very elements that make up our bodies are forged in a cataclysm that can outshine entire galaxies. This structure of creation through destruction is the fundamental rhythm of the cosmos, where the death of a star provides the seeds for the birth of a new world. Surprisingly, the universe requires the most extreme environments to produce the complexity and variety that we see in the night sky. Notice the profound calm in your own environment, a rare sanctuary that exists only because of the distant, violent energies that shape the elements of your world. We are children of the stars, born from a chaos that is as terrifying as it is magnificent. As you drift towards sleep, let the duality of the universe wash over you, a reminder of the power and the beauty that coexist in the deep. We have extended our senses billions of miles outward using fragile structures of metal and wire, reaching out into the unknown with the curiosity of a child reaching for the stars. These robotic surrogates are the thin, electrical nerves of our species, feeling the cold, the heat, and the radiation on our behalf in places where our own bodies could never survive. Through these metal messengers, we have touched the rings of giants and mapped the surface of the most distant ice dwarfs. This structure of technology acts as a secondary nervous system for humanity, allowing us to virtually inhabit worlds that are light years away. The profound, echoing silence of an expanding emptiness stretching toward infinity is no longer a barrier, but a vast field of exploration that we've begun to navigate with increasing precision. If we were to look closer at the internal circuits of these machines, we would see the collective knowledge and dreams of 1,000 scientists etched into every silicon chip. Slowly, these machines are becoming our permanent representatives in the dark, silent ambassadors that will outlast the civilizations that built them. They carry our questions into the void and bring back the answers in a stream of radio waves that connect us to the infinite. Feel a sense of pride and peace in this achievement, knowing that the reach of human curiosity is as vast as the universe itself. We build these lonely, wandering machines not merely to measure the cold expanse of the universe, but to understand the warm, fleeting miracle of our own existence. Deep within the silicon hearts of our distant voyagers, the final truth of our exploration begins to crystallize in the absolute quiet of the interstellar void. This structure of human intention, launched from a single pale blue dot, has travelled for decades just to look back at the origins of its own curiosity. Surprisingly, the farther we reach into the dark, the more we find ourselves examining the light of our own home. We build these lonely, wandering machines not merely to measure the cold expanse of the universe, but to understand the warm, fleeting miracle of our own existence. If we were to look closer at the data streaming across the billions of miles, we would see it is not just a census of rocks and gas, but a desperate, beautiful love letter to the planet that remains our only sanctuary. This journey into the unknown has taught us that the greatest discovery was never a distant world, but the realization of how precious it is to be alive and aware in such a vast, unanswering cosmos. As these cosmic wonders settle into the back of your mind, allow the weight of the journey to ground you in the absolute stillness of your own space. Surprisingly, the body responds to the profound, echoing silence of an expanding emptiness by seeking the security of the present moment. If we were to look closer at the physical sensation of your rest, we would find a landscape as deep and peaceful as any corner of the solar system. Begin by bringing your awareness down to the tips of your toes, feeling the subtle release of any lingering tension from the day. This quiet room provides a sanctuary where your feet can finally rest, heavy and supported by the softness beneath you. Notice the gentle warmth spreading through your arches and up into your ankles, a slow tide of relaxation that claims every muscle in its path. Your calves and knees now sink deeper into the mattress, shedding the weight of the day's movement like a probe shedding its heat shield. This structure of your legs is becoming completely still, grounded in a state of effortless peace that reaches through the bone. As the relaxation travels higher, your thighs and hips feel broader and heavier, fully surrendered to the comfort of the bed and the pull of the earth. Deep within your lower back, the muscles begin to uncoil and soften, releasing their hold on the physical world. The rhythmic rise and fall of your abdomen mirrors the slow, steady pulse of a quiet planet orbiting a distant sun. If we were to look closer at the center of your chest, we would find a heart that is beating with a calm and quiet strength, untroubled by the distance it has traveled. The hands rest motionless at your sides, the fingers curling naturally as they release all effort and intention. This deep sense of ease flows up through your wrists and forearms, bypassing the joints to settle in the upper arms. Every muscle in the forearms and biceps simply lets go, becoming as light as the vacuum and as heavy as lead all at once. Moving upward, the relaxation claims the shoulders and the back of the neck, areas that often carry the weight of the world. This quiet room is filled with a stillness that is both heavy and light, a blanket of silence that covers every corner. Surprisingly, the body knows exactly how to let go, allowing the breath to become a slow and shallow tide that requires no effort at all. Every tiny muscle around your eyes and mouth begins to smooth out, disappearing into a mask of total tranquility. This quiet room is your own private universe of rest, where the only thing that matters is the steady flow of the air. If we were to look closer at the mind, we would see the thoughts drifting away like leaves on a still pond, leaving behind only the calm. The breath is a slow, rhythmic anchor that pulls you deeper into the velvet darkness of a dreamless state. Everything is soft, everything is heavy, and everything is exactly as it should be. The mattress supports you completely, a firm and gentle foundation for the long, restorative hours of the night. A profound sense of peace fills the space around you, a warmth that is both internal and external. You are safe, you are still, and you are ready to disappear into the healing embrace of the dark. The room is a sanctuary of shadow and comfort, where the only light is the soft glow of your own fading awareness. And now, 101 wonders are resting with you. Sleep now. Good night.